Congratulations again for enrolling in this course. I can't tell you how excited I am to teach you all of these new technologies. Allow me to share some insights on how to maximize the benefits of this course. My first advice is to go through this training using a laptop or a PC, since we are going to work with a lot of code and you are going to have to keep pace. Watching this course on a smartphone is something that I strongly do not recommend. This course requires some basic Python programming experience, and for that I have added some videos on basic Python programming at the end of the course as a bonus section. But if you are a complete beginner in Python and you feel overwhelmed, you should consider taking my Python bootcamp, where I started from scratch and I go really deep into Python. If there's something not clear, don't hesitate to get in touch with me or with the other students. Use the Q&A section of the course or join our online community. Let me tell you just a few words about the Udemy player. This course is for a wide audience. If I speak too slowly for you, click the playback rate and speed up the video. If you are already familiar with the topic and want to make sure that you don't miss anything, set the speed to 1.5 or 2x. Early on in the course, Udemy will ask you to leave a review. You can write it at that time, or if you prefer to gather your thoughts, you can select Ask Me Later. I want to let you know how incredibly important these reviews are for me as an instructor. They help me to improve my courses and keep me motivated to create new and better content. So thank you in advance for taking the time to leave a review. Before we get started with LangChain, Pinecone, OpenAI, and all of these amazing technologies, I'd like to show you a demo of what they can do as we progress. We'll be following a learning by doing approach, and what you see next is what we'll be doing together, step by step, line by line, throughout this course. After a short introduction to LangChain, we'll dive into its main components. We'll talk about LLM wrappers, chains, and agents, and how to combine them with the Pinecone vector data store and with OpenAI's models. After this big section, we'll move on to the project sections. Let's take a look at one of them. Let's imagine that you want to start a business in the EU. All EU business entities must follow the GDPR regulation, which was implemented by the European Union to protect the privacy and personal data of EU citizens. It standardizes data protection laws across all EU member states and imposes strict rules on controlling and processing personally identifiable information. If you don't comply, you could be fined hundreds of thousands of euros and your business could be closed. This is not a joke. Here is the GDPR website. As you can see, there are tens of chapters and the PDF file is 88 pages long. You could probably spend a few full days reading and understanding it, or you could hire a specialized lawyer to explain it to you, and that's not a cheap job. Alternatively, you could build an LLM application that learns the content of this document so that you can ask it questions about anything related to it. It's like having that expensive lawyer in front of you, but for free. I used this example because it's something that's well known and of interest in Europe. But you could use any other private document, instruction manuals, legal or accounting documents, medical studies, treatment plans, and so on. The AI model was not trained on this set of data because it's not public or is too recent. Once you build the application, you can use it with any other document. I'm loading the 88-page PDF into a LangChain document. I'm running the code in this cell. It's loading the file. Now, I'm splitting it into smaller chunks. There are 856 chunks. Next, I'll embed the chunks into numeric vectors and insert them into a Pinecone index. I'm running the code. It's embedding the chunks, creating the Pinecone index, and inserting both the chunks and the embeddings into the Pinecone index. It takes some time, so I'm pausing the video until it's done. It is done, and the embeddings are now in the Pinecone index, the vector embeddings. Let's ask a few questions. I'm running this piece of code. And the first question will be, what are the main points described in the document? And I've got the answer. Okay, let's ask, what is GDPR? What is GDPR? And it says that GDPR stands for General Data Protection Regulation, and that it is an EU law. Very good. The next question. Tell me more about the requirement for consent, please. Very good. And the last question. What about the right to be forgotten? This is something very interesting. This is the answer. All the answers were given only based on the content of that document. You can use any other document in any format instead. This is amazing, and in my opinion, this opens up an infinite number of use cases. We'll probably add the application, a fancy web interface, and that's it. This was one of the many useful projects we will build throughout this course. We will also build a summarization system, which is a valuable tool for anyone who needs to summarize large amounts of text, such as students, researchers, and business professionals. I will also teach you how to create web interfaces for these applications so that you can actually sell or use them in real life. There is so much to come. Let's get started. This first lecture will be an introduction to LangChain. You'll learn what it is, its use cases, and its components. After this theoretical lecture, we'll move on to coding. What is LangChain? LangChain is an open source framework that allows developers working with AI to combine large language models or LLMs like GPT-4 with external sources of computation and data. The framework is currently offered as a Python or a JavaScript package and is under heavy development. It is used to build complete apps using LLMs very quickly. Using LLMs is often insufficient for creating truly powerful apps. This is because LLMs are often limited in their ability to understand the context, interact with the real world, or learn and adapt. To understand what needs LangChain fills, let's look at a practical example. We all know that LLMs such as ChatGPT and GPT-4 have an impressive general knowledge. We can ask them about almost anything and get a pretty good answer. But what if you want to know something specific from your own data, your own documents? It could be a book, a PDF file, or a database with proprietary information. LangChain allows you to connect a large language model like GPT-4 to your own sources of data. This is what data-aware means, and LangChain is data-aware. Of course, you can give the information to the AI model as input into the prompt, but I'm talking about something else. I'm talking about referencing an entire database filled with your own data. Using LangChain, you can make GPT-4 work with your own data, and it can also take the action you'd like. For instance, search the web, fill out a form, or send an email with some specific information. This is what agentic aware means. So LangChain is data aware and agentic aware. The example I've described to you works like this. You take the document you want your language model to reference and slice it up into smaller chunks. Store those chunks in a vector database as embeddings, which are numeric representations of the text. In fact, you know very well what embeddings are from the first part of the course. These capabilities open up an infinite number of practical use cases. Just imagine the possibilities. You can have a large language model that references the constitution or the civil code of your own country. You can ask the application anything about the constitution or the laws you are interested in, and the application will give you the correct answer. It's like having a specialized lawyer in front of you that can be asked anything for free. This will open up a world of new opportunities. I believe we are going to see exponential progress in data analytics and data science. Our ability to connect large language models to advanced APIs is really going to take things to the next level. LangChain implements abstractions like chains and agents so that a developer doesn't have to know what happens under the hood. Let's go over some specific examples of applications that can be created using LangChain. Chatbots, question answering systems, or summarization tools. LangChain can be used to create chatbots that can interact with users in a natural way. For example, you could use LangChain to create a chatbot that can answer customer questions or provide support based on the internal documentation of the company. LangChain can be used to create question answering systems that can answer questions in a comprehensive and informative way. For example, you could use LangChain to create a question answering system that can answer questions about a particular product, service, or topic, such as history, science, or current events. LangChain can be used to create summarization tools that can summarize long pieces of text in a concise and informative way. For example, you could use LangChain to create a summarization tool that can summarize documents, news, articles, research papers, or even books. These are only a few of the applications that can be built using LangChain. When learning LangChain, you will actually learn about three main concepts: LangChain components, chains, and agents. Let's see the LangChain components. First off, we have the LLM wrappers that allow us to connect to and use large language models like GPT-4 or those from the Hugging Face Hub. Next, there are the prompt templates that allow us to create dynamic prompts which are the input to the LLMs. Indexes allow us to extract relevant information for the LLMs, and memory is the concept of storing and retrieving data in the process of a conversation. There are two main types of memory: short-term and long-term. Short-term memory generally refers to how to pass data in the context of a single conversation, and long-term memory deals with how to fetch and update information between conversations. Chains allow us to combine multiple components together to solve a specific task and build an entire LLM application. And agents facilitate interaction between the LLM and external APIs. They play a crucial role in decision-making, determining which actions the LLM should undertake. Agents are enabling tools for LLMs. This process involves taking an action, observing the result, and then repeating the cycle until completion. Okay, we'll take a break, and in the next video, we'll move on to coding and go deeper into each LangChain concept. In the previous lecture, you learned what LangChain is, what needs it fills, and its components. Let's move on to coding. In this video, we'll set up the environment. We'll install the required libraries and set up the API keys using python.env. We can install the libraries using pip install and the name of the libraries, like we've done so many times, or we could write the name of the libraries in a text file called requirements.txt and then run pip install -r requirements.txt. I'm creating a file in the current directory and adding the necessary libraries. The name of the file will be requirements.txt. And the necessary libraries are OpenAI, LangChain, Pinecone client, python-env, and the tick token. We'll use them in this section of the course. I'm saving the file and I'm running pip install -r requirements.txt from the current directory. And -q for quiet. I'm running the cell. It's running. Now it's installing the libraries. If you run Python in a virtual environment, run pip without the exclamation mark. I'm pausing the recording until it's done. To see the version of a library like LangChain, run pip show LangChain. Note that LangChain is under heavy development. It is one of the most popular Python libraries at the moment, and the new versions are released every few days. Take a look here. The latest version was released 3 hours ago. This one yesterday, this one 2 days ago, and so on. 1 month for LangChain is like a year in human time. You can check the latest version on GitHub under releases. As you can see, a new version is released almost on a daily basis. You'll probably find here another version when you run the command on your computer. If you find something different, then in my examples, please get in touch with me. I'll update it as soon as possible. When you want to upgrade the library to its latest version, run pip install LangChain -upgrade -q. Let's talk about python.env we've just installed. Python.env is a popular module that allows you to specify environment variables as key value pairs in a .env file within your Python project directory. It's a convenient and secure way to load and use environment variables in your application. You'll find python.env used in many Python applications. In this case, we'll have more than one API key and we'll save them all in .env. We'll have an API key for OpenAI, another one for Pinecone, a key for Hugging Face, and so on. Using a text editor, I'm creating a text file in the current working directory and adding OpenAI API key equals and the key in double quotes. Let's suppose we've already created an OpenAI account and generated an API key. If not, go to platform.openai.com and sign up for a new account. Then log in, click your organization name, and view API keys. Here, you can generate a new API key or invalidate an existing one. In the sections that follow, we'll also use Pinecone, which is a high-performance, scalable, and distributed vector store for LLMs. Go to pinecone.io and sign up for a free account. Log into your account and go to API keys to generate a new one. Enter a name and generate it. I'm generating a new key. Now copy both the key value and the environment to .env like this. The name of the variable will be Pinecone API key equals and the key. And the Pinecone env equals and the environment name. And I'm adding an OpenAI API key as well. Now, I have to save this file as .env. File, save as. I'm selecting all files and its name will be .env. This is the file. You will open it with any text editor. Here, I would have one more remark. On Linux and macOS, file names that start with a dot are hidden and are not displayed by default in the File Explorer. Go to the settings and select to see them as well. Let's load the environment variables. Import OS and from .env, import load.env and find.env. I'm running the cell. If you get the module not found error, like this, then restart the kernel. If you still get the error, the problem may be that you run Python in a virtual environment. If you run Python in a virtual environment, run this command pip install without the exclamation mark. Exclamation mark pip installs the packages in the base environment, and the pip without the exclamation mark installs the packages in the virtual environment. So run it again like this. In fact, I'm writing this down. Exclamation mark pip installs the packages in the base environment. And pip installs the packages in the virtual environment. Let's move on. Now I'm calling load.env to load the variables found in .env in this file. I can give the path to .env as an argument like this. It's in the current directory, or I can call find.env like this. Find.env tries to find the .env file. And I'm adding a second argument, override equals true, to override the value of the variable if you change it in .env. So find.env returns the path to the file if found, or an empty string otherwise. Now the environment variables are loaded and I can use them. Let's see one of them. os.environ.get of and the name of the variable. For example, Pinecone API key. Good. We've successfully set up the environment. In this video, we installed the necessary libraries, obtained the API tokens for OpenAI and Pinecone, and loaded them as environment variables in our application. We'll pause here briefly. In the next video, we'll explore LangChain's components and demonstrate how to invoke various AI models. Welcome back. We'll start a new section and see how LangChain deals with different types of AI models. We'll cover 3 types of models: simple LLMs, chat, and embedding models. Let's start off with simple LLMs and see an example with GPT-3. It takes a string as input and returns a string as output. I'm importing the OpenAI class. So from LangChain.LLMs, import OpenAI. I'm creating an LLM object. So LLM equals OpenAI of model name equals text DaVinci 003, temperature equals, let's say, 0.7, and the max tokens equals 512. And I'm printing the parameters of the LLM. And you see here the model name, the temperature, the max tokens, and so on. The LLM class is a class designed for interfacing with LLMs. There are lots of LLM providers, OpenAI being one of them. This class is designed to provide a standard interface for all of them. Now we are calling it. We are passing a string and we'll get back another string. Output equals LLM of and the prompt. Explain quantum mechanics in one sentence. This is similar to calling OpenAI API directly. And I'm printing the output. I'm running the cell. Great, I've got the answer. If you want to estimate the number of tokens in this request, you can call LLM.getNumTokens. LLM.getNumTokens and the prompt. There are 7 tokens. More broadly, you can call it with a list of inputs, getting back more outputs or a more complete response than just the text. Let's see an example. Output equals LLM.generate and the list. The first question. 3 ducks is the capital of France. And the second question. What is the formula for the area of a circle? I'm running it. Of course, the name of the method is generate. I'm running it. And print output dot generations. And we see the generations. We see the answer for the first question, Paris, and the answer for the second question. The formula for the area of a circle. If you want to get only one answer, use output.generations of 1 of 0.txt. This is the answer to the second question. And this is the answer to the first question, index 0 and index 1. If you want to check how many generations it gave, you can call the len function. And there are 2 generations. You can also request more than one answer like this. Output equals LLM.generate. Write an original tagline for a burger restaurant. Times 3. I want 3 answers. Okay, if you get this warning, rate limit error, you can wait a few seconds and run it again. And to see each answer, you can use a for loop. For example, for O in output.generations, print O of 0.text. And we can see the taglines. Great! We are done with simple LLMs like Text DaVinci 003. In the next video, we'll see how to use chat models like GPT 3.5 Turbo or GPT-4 with LangChain. Welcome back. Let's go ahead and see how to use chat models like GPT 3.5 Turbo and GPT-4 with LangChain. Chat models are a variation on classical language models. Rather than expose a text-in, text-out API, they expose an interface where chat messages or conversations are the inputs and outputs. First off, we have to import a schema for the structure called messages. From LangChain.schema, import AI message, human message, and the system message. Take a look here. Remember that the OpenAI API for GPT 3.5 Turbo and GPT-4 uses a list of dictionaries called messages. This can define 3 roles: system, user, and assistant. The system role helps set the behavior of the assistant. The user message is what we ask the assistant, and the assistant messages help store prior responses. Here in LangChain, AI message is the equivalent of the assistant message, human message is the equivalent of the user message, and the system message is the system message in OpenAI API. Next, from LangChain.chat models, I'll import chat OpenAI. I'm creating the chat object like this. Chat equals chat OpenAI of model name equals GPT 3.5 Turbo, temperature 0.5, and the max tokens equals 1024. If you want to use GPT-4 instead of GPT 3.5 Turbo, just change the name of the model. And the messages list. So, system message, content equals, you are a physicist and respond only in German. I'm setting the behavior of the assistant. And the human message, what we are asking, this is in fact the prompt, content equals, I'll ask the same question. Explain quantum mechanics in one sentence. And the output equals chat of messages. I'm running the cell and printing the output. Sometimes you can get a warning like this. You can ignore it or wait a few seconds and run the code again. The model can be overloaded with many other requests. And if you want to see only the text, use output.content. This is the answer in German. Alright, in this video, we learned how to call OpenAI's chat models from LangChain. We'll take a break, and in the next video, we'll go over prompt templates. Let's go ahead and talk about another core component of LangChain called prompt templates. A prompt refers to the input to the model. Prompt templates are a way to create dynamic prompts for LLMs that are more flexible and easier to use than traditional static prompts. They are built on the top of the Jinja 2 templating language. A prompt template takes a piece of text and injects a user's input into that piece of text. Let's see how to create and use a prompt template. From LangChain, I'm importing the prompt template class. I'm creating a multi-line string variable called template. This is similar to an F string and uses curly braces for the dynamic part of the template. So, you are an experienced virologist. Write a few sentences about the following and virus in curly braces, this is the dynamic part, in and the language in curly braces. This prompt has two input variables, virus and language. Now I'm defining a prompt object of the class prompt template. So prompt equals prompt template of, and there are two arguments. Input variables equals and a list with the name of the variables, virus and language. So virus and language, and the template equals template. The first template variable is the argument of the constructor, and the second one is my variable. Note that this list contains the variables expected by the prompt. I am printing the prompt. And I'm running it. This is the prompt object. Next, I'll create the LLM object. From LangChain, LLMs, import OpenAI. And LLM equals OpenAI of model name equals text DaVinci 003 and the temperature equals 0.7. And I'll call the LLM with the prompt.format method as an argument. So output equals LLM of prompt.format of virus equals Ebola, and the language equals Romanian, my native language. I'm printing the output. I've got an error because there's a small typo. I have misspelled the word temperature. And it generated a few sentences about the Ebola virus in Romanian. Some benefits of using prompt templates are reusability, scalability, and accuracy. For example, if I want a description of another virus in another language, I can simply change the arguments of the prompt.format function and not the entire prompt. Now I want a description of HIV in German. Great! We are done with prompt templates for the moment. Please take your time to fully understand them as they are a key component of LangChain. We will use prompt templates in every application we build with LangChain. Hi! So far, you've learned about LLM wrappers and how to call OpenAI's models. You also learned about prompt templates and how to use them. Now, let's move on and talk about chains. Large language models can be used for a variety of tasks, but they are often limited in what they can do on their own. For simple tasks or applications, you can use LLMs in isolation. For more complex tasks, it is often necessary to chain or combine different components. Chains allow us to combine multiple components together to create a single, coherent application. For example, we can create a chain that takes user input, formats it with a prompt template, and then passes the formatted response to an LLM. LangChain provides a standard interface for chains as well as some common implementations of chains to make it easy to create and use chains. There are simple, sequential, and custom chains. In this video, I'll show you how to create and use a simple chain. I will import the necessary libraries. Although these libraries may have been imported in the preceding cells, I will re-import them all. This is to ensure that the entire code within this cell is self-contained and can be executed independently. From LangChain.chat models, I am importing chat OpenAI. And from LangChain, I am importing prompt template. And from LangChain.chains, I'm importing LLM-chain. I'm creating the LLM object that uses GPT 3.5 Turbo. Use any other model if you want. So LLM equals chat OpenAI of model name equals GPT 3.5 Turbo. This is the default anyway. And the temperature equals 0.5. Now, the prompt template. I'll use the same prompt as before. In fact, I'll copy and paste the code to save some time. I have already written and explained it to you in the last video. I have the LLM and the prompt template, and I can create the chain. Chain equals LLM chain of LLM equals LLM and prompt equals prompt. The LLM constructor creates a simple chain that takes in a prompt template, formats it with the user input, and returns the response from the LLM. Finally, we have to run the chain only specifying the input variable or variables. So output equals chain.run of, and I have a dictionary. Virus, colon, let's say HSV, and the language, colon, French. I'm running it. Okay, there's a spelling error. The name of the model is GPT 3.5 Turbo. I'm running it again. I'm also printing the output. And I've got the description of this virus in French. In this example, the prompt template requires two variables, virus and language. But if it requires only one, you can call chain.run with a string variable as an argument instead of a dict. Like this. Output equals chain.run HSV. And I'm removing the second variable. I'm running it. The output will be probably in English. Of course, it's in English. Good. I'm adding two variables again. This is a more general form. Great, we are done. In this video, we discussed simple chains, which are the most basic type of chain. They consist of a single LLM that is used to perform a single task. For example, a simple chain could be used to generate text by passing a prompt to an LLM. Simple chains are easy to create and use and also relatively efficient. However, they are limited in what they can do. For more complex tasks, it is often necessary to use sequential chains. We'll take a break, and in the next video, we'll talk about sequential chains. In the previous video, we talked about simple chains. They are easy to create and use, but they are limited in what they can do. For more complex tasks, it is often necessary to use sequential chains. In this video, we will discuss sequential chains. With sequential chains, you can make a series of calls to one or more large language models. You can take the output from one chain and use it as the input to another chain. There are two types of sequential chains: simple sequential chains and the more general form of sequential chains. Simple sequential chain represents a series of chains where each individual chain has a single input and a single output, and the output of one step is used as input to the next. For example, you could create a simple sequential chain that first asks a question to an LLM, then takes the answer from the first LLM and uses it as the input to a second LLM to get a more detailed answer. I'm importing all required libraries. I'm gonna use two different AI models, so I'm gonna import OpenAI as well. OpenAI is used for Text DaVinci 003 and Chat OpenAI for GPT 3.5 Turbo or GPT-4. And from LangChain chains, I'm importing LLM-chain and simple sequential chain. Now, I'm defining the first LLM. LLM1 equals OpenAI of model name equals Text DaVinci 003 and the temperature equals 0.7. and the max tokens equals 1024. This is the first LLM for the first chain. Now I'm defining the first prompt. Prompt 1 equals prompt template of input variables equals and a list with a variable concept, and the template equals a multi-line string. You are an experienced scientist and Python programmer. Write a function that implements the concept of concept. Concept in curly braces because it's a variable. It's the dynamic part of the prompt. And I'm defining the first chain. Chain 1 equals LLM-chain of LLM equals LLM1 and the prompt equals prompt 1. And I'll do the same for the second chain. I'm defining the second LLM. This time I'll use GPT 3.5 Turbo or GPT-4. So chat OpenAI of model name equals GPT 3.5 Turbo and the temperature, and I'll use another value. For example, 1.2. And the second prompt. Prompt 2 equals prompt template of input variables equals and a list with a single element function, and the template equals, pay attention that it's template, sorry, there was a typo, given the Python function describe it as detailed as possible. And the second chain, chain 2 equals LLM chain of LLM equals LLM2 and the prompt equals prompt 2. There are two LLMs, two prompt templates, and two chains. Now I'm defining a sequential chain using the two chains above. The second chain takes the output of the first chain as input. Overall chain equals simple sequential chain of chains equals and a list of chains, chain 1, chain 2. And I can add verbose equals true to see what it's doing. I'm running the overall chain specifying only the input variable for the first chain. Output equals overall chain dot run of and let's say linear regression. The first chain will write the function for linear regression, and the second one will describe it as detailed as possible. I'm running it. Here it is prompt. Okay, and here is GPT. Now it's okay. I'm running it. It's entering the new simple sequential chain. In a few seconds, we'll see the implementation for linear regression in Python. We'll see the function. And after that, we'll get a description of it from the second chain. Great. This is the function and the description. We are waiting a few more seconds. This is the description of it. If you want another concept, you can simply replace linear regression with, let's say, softmax. This is another important data science and machine learning concept. I'm running it again. And we'll see the implementation and the description of softmax. Great job! Now you know what chains are and what they can do. You also learned that there are two types of chains: simple chains and sequential chains. The type of chain you use will depend on the task you are trying to accomplish. If you are trying to do a simple task, a simple chain might be enough. But if you are trying to do a complex task, a sequential chain might be necessary. In this lecture, we will start diving into agents. Large language models are incredibly powerful, but they lack the ability to perform certain tasks that even the simplest application can do easily. For example, LLMs struggle with logic, calculation, or communicating with other external components. Let's see an example. I'm asking GPT-4 for the result of an exponentiation. What is the answer to 5.1 to the power of 7.3? And the GPT-4, probably the most complex computer application that has been ever built, fails. Calculating powers where the exponent is not a whole number is a complex operation and can't be done by an AI model. This is not the good result. This operation can be done easily by any calculator. For example, in Python, you would use the double star operator. So, 5.1 star star 7.3. And I've got a completely different answer. Let's try another one. 5.1 to the power of 1.7. And once again, GPT-4 fails. Let's do this again using Python. As you can see, the answer is different. This is because GPT-4 is using an approximation, while Python is using the exact mathematical formula. In conclusion, LLMs are powerful tools, but they are not perfect. They can be used to generate text, translate languages, and answer questions, but they cannot replace calculators or other tools that are designed for specific tasks. Let's try another one. I'm giving ChatGPT the task of writing an article about LangChain agents. So write an article about LangChain agents. We see how it hallucinates. Nothing from what you see here is true. It completely made up the answer. That's because it was trained on data that cuts off in late 2021. You could say that there are plugins that help GPT-4 browse the internet and access updated information, but that's something different. Plugins are external tools that are similar to agents. One solution to these problems is to use LangChain agents. Agents are enabling tools for LLMs. Using agents, LLMs can run code, do calculations, search the web, or run SQL queries. Now that you've learned why we need agents and what they are, we'll take a break, and in the next video, we'll see LangChain agents in action. We've seen that LLMs lack the ability to solve complex calculations, So we are going to take another approach. Instead of having the LLM generate the answer directly, which is difficult, we'll instruct the LLM to generate the Python code to calculate the answer and then run that code in a Python interpreter to get the answer, the final answer. I'm importing create Python agent and the Python REPL tool. I'm also importing OpenAI. I'm creating the LLM. LLM equals OpenAI, temperature equals 0. I'm instantiating a Python agent executor using an OpenAI LLM. This allows us to have the language model execute Python code. So agent executor equals create Python agent of, and the arguments are LLM equals LLM, tool equals Python REPL tool, the class we've just imported, and the verbose equals true. I want to see the intermediate steps. In this function, create Python agent, there's an argument named tool. Tools are essentially functions that agents can use to interact with the outside world. These can range from general utilities such as a math calculator or a search function to other chains or even other agents. I'm executing the Python agent. The problem to solve is given in natural language format. So agent executor dot run of, and the problem. Let's give it a difficult problem. Calculate the square root of the factorial of 20 and display it with 4 decimal points. I want to display this problem on 2 lines. So I'm adding a \n and a new line. Good. And I'm running it. It's entering the new agent executor chain. Thought, action, action input, observation, thought, and so on. It will generate the Python code and run it. This is the Python code. And this is the final answer. I can run the code in Python by myself. And I've got the same answer. I'm assigning it another task. This time it's to calculate an exponentiation. Both the base and the exponent are floats, and the GPT-4 alone failed to provide the correct answer. I'll give it the same task. I'm copying it to clipboard. So agent executor dot run and the task. And I'm running it. You are now looking at the process of how an LLM generates Python code. The LLM first makes a plan, then an observation, and finally a thought. If it generates some code that doesn't work at first, it will think of the error and generate another piece of code. Finally, it runs the code and we receive the correct answer. This is the correct answer, and it's different from the one given by GPT-4. Let's test the answer in Python REPL. So 5.1 to the power of 7.3. And it's the same result. Great! Congratulations on reaching this far. You are doing fantastic. You've learned a lot about LangChain. You now know how to connect LangChain to LLMs, create and use prompt templates, build simple and sequential chains, understand LangChain agents, what they are good at, and how to use them. We'll take a break now. In the next lectures, we'll cover embeddings, vector stores, and similarity search. Embeddings are the core of building LLMs applications. Let's do a short recap of embeddings. Text embeddings are numeric representations of text and are used in natural language processing and machine learning tasks. Text embeddings can be used to measure the relatedness and similarity between two pieces of text. Relatedness is a measure of how closely two pieces of text are related in meaning. In this context, the distance between two embeddings or two vectors measures their relatedness, which translates to the relatedness between the text concepts they represent. Text concepts are words and phrases. Similar embeddings or vectors represent similar concepts. There are two common approaches to measuring relatedness and similarity between text embeddings: cosine similarity and Euclidean distance. We'll find these often used when working with embeddings. Some examples of how text embeddings can be used to measure relatedness and similarity are text classification, which is the task of assigning a label to a piece of text; text clustering, which is the task of grouping together pieces of text that are similar in meaning; and question answering, which is the task of answering a question posed in natural language. In the first part of the course, covering OpenAI's API, we took a deep dive into embeddings. If you feel the need, I recommend revisiting those sections for a refresher. We'll now take a quick break. In the next video, we'll discuss vector databases. These databases are designed for storing and querying high-dimensional vectors efficiently. In this video, we'll talk about vector databases. The AI revolution is here, and it is about to change the world. AI is being used in a variety of industries and has the potential to improve our lives in many ways, but it also introduces new challenges. One of the biggest challenges is efficient data processing. AI applications such as LLMs, generative AI, and semantic search require large amounts of data to train and operate. Efficient data processing is essential for making AI applications successful. Many of the latest AI applications rely on vector embeddings. Chatbots, question answering systems, and machine translation rely on vector embeddings, which, as you know, means converting text to numbers that carry within themselves semantic information. Vector embeddings are a way of representing text as a set of numbers in a high-dimensional space, and the numbers represent the meaning of the words in the text. This is critical for the AI to gain understanding and maintain long-term memory. One application that we built in the first part of the course was a book recommendation system. This utilized a dataset from Kaggle, which contained information about thousands of books. We transformed the book description into vectors using an AI model and stored both the description and its corresponding embedding in a CSV file. These are the embeddings. Whenever a user inputs a book title that is found in the dataset, the application retrieves the corresponding description embedding and calculates the closest embeddings. Similar embeddings suggest comparable text descriptions. The application operated satisfactory, but storing extensive data in a CSV file proved to be highly inefficient. The CSV files increased dramatically. For instance, For this application, the file with 5,000 embeddings is over 200 megabytes. Imagine the size it would reach if we were to embed millions or even billions of text records. Consequently, we need a specialized database or data store specifically designed to manage such large quantities of data in a numeric representation. There are many vector databases available, both free and commercial. Some of the most popular ones include Pinecone, Chroma, Milvus, or Quadrant. In this section of the course, we'll use Pinecone. Pinecone is a vector database designed for storing and querying high-dimensional vectors. It provides fast and efficient semantic search over these vector embeddings. By integrating OpenAI's LLMs with Pinecone, we combine deep learning capabilities for embedding generation with efficient vector storage and retrieval. Vector databases are a new type of database designed to store and query unstructured data. Unstructured data is data that does not have a fixed schema, such as text, images, and audio. SQL databases, on the other hand, are designed to store and query structured data, which has a fixed schema. In a traditional SQL database, we usually query for rows where the values match specific criteria. Think of the SQL select statement. In vector databases, we apply a similarity metric to find a vector that is the most similar to our query. What is the common pipeline for vector databases? Vector databases use a combination of different optimized algorithms that all participate in approximate nearest neighbor search. Take a look at this image. To understand how vector databases work, let's break down the image into 3 steps: embedding, indexing, and querying. The first step, embedding, is to create vector embeddings for the content we want to index. This is done by using an embedding model such as OpenAI's Text Embedding ADA 002. The second step, indexing, is to insert the vector embeddings into the vector database. This is done by associating each vector embedding with a reference to the original content that was used to create it. And the third step is query. The third step is to query the vector database for similar content. This is done by using the same embedding model used to create the vector embeddings. The embeddings model is used to create a vector embedding for the query, and this vector embedding is then used to query the database for similar vector embeddings. The similar vector embeddings are then associated with the original content that was used to create them. To illustrate, let's imagine a company that wants to store and query its private documents. The company would first use an embedding model to create vector embeddings for each document. These vector embeddings would then be inserted into a vector database such as Pinecone. Each vector embedding would be associated with a reference to the original document. Finally, the company can use the vector database to query for information that is similar to a given query or question. For instance, the company could query the documents or to a product description. Vector databases are much more efficient at storing and querying unstructured data and are heavily used in LLM's applications. Alright, we are done. That was a short introduction to vector databases. In this lecture, you learned what a vector database is, why we need them, and how they leverage the power of the next generation of AI applications. We will take a break, and in the next video, we will dive into Pinecone. This is the first step in working with OPL stack and developing LLMs applications. The OPL stack is a set of open source tools that can be used to build applications that use large language models. The stack consists of three main components: OpenAI, Pinecone, and LangChain. I'll see you soon. In the last video, we talked about vector databases, what they are and why they are needed. In this lecture, we will dive into Pinecone, one of the most popular vector databases. At the beginning of the course, we set up the environment and sign up for a Pinecone account. We have a Pinecone API key in a .env file in the current directory. This is the file, and I am opening it using Notepad. This is the Pinecone API key, and this is the Pinecone environment. You should keep the API key secure. In my case, I'll rotate or generate another key after recording this video. I'll do the same for all the keys shown in this course. I'm loading them as environment variables using python.env. I'm importing Pinecone and initializing the Pinecone client. Import Pinecone. And the Pinecone init of API key equals os.environ.get and the name of the variable, the one found in .env. So Pinecone API key. And the second argument, environment, equals os.environ.get and the name of the variable, Pinecone env. I'm running the cell. This is just a warning and you can ignore it. To see the versions of both the client and the server, run pinecone.info.version. Let's go ahead and talk about Pinecone indexes. An index is the highest level organizational unit of vector data in Pinecone. It accepts and stores vectors, serves queries over the vectors it contains, and does other vector operations over its contents. Each index runs on at least one pod. Pods are pre-configured units of hardware for running a Pinecone service. I am also logging in the web interface. At the moment, there's no index. Let's list all indexes. So Pinecone dot list indexes. And I've got an empty list. Let's create a vector index. So index underline name equals, let's say LangChain Pinecone. I'm creating the index only if it doesn't already exist. Note that if you are using the free plan like I do, you are limited to one index and one project. So if index name not in Pinecone dot list indexes, if it doesn't exist, I'm creating it. I'm printing a message for the user, creating index name in curly braces and three ducks, and Pinecone dot create index of index name, dimension equals 1536. This is the dimension of OpenAI's embeddings, it will use the cosine similarity as a metric, so metric equals cosine, pods equals 1, and the pod type equals p1.x1. You can change these variables only if you use a paid plan. And I'm printing done. And else, if the index already exists, I'm printing index and xname already exists. I'm running the cell. Note that creating an index takes some time. I'm also refreshing the Pinecone dashboard to see how the index is created and initialized. This is the index. It's initializing it. It's still running. This star in brackets means that it's still running the code. To see information about an index, run pinecone.describe index and the index name as an argument. I'm waiting for it to finish. And I'm running the code. And we see information about the index. Let's take a look at how to delete an index. Index name equals, and the name of the index I want to delete. LangChain Pinecone. I'm deleting the index only if it already exists. So if index name in pinecone.listIndex is, I'm deleting it. So print deleting index. And I'm calling pinecone.deleteIndex of index name. And print done. And else, if the index doesn't exist, I'm just printing a message for the user. Index name in curly braces does not exist. I'm running it. It's deleting the index, and I'm refreshing the page. And the index is gone. Good. I'm creating the index again. To do any operation with an index, you must first select it. So index underline name equals, and the name of the index I want to work with. LangChain Pinecone. And the index equals pinecone.index with a capital I, index name. I am selecting the index. Now I am displaying some statistics. I'm calling index.describe index stats. And I'm running the cell. If you get a service exception, wait until the index is initialized and run the code again. Okay, it's ready, and I'm running the code again. And we see the dimension and the total vector count. The index is empty. Another important concept is the namespace. Pinecone allows you to partition the vectors in an index into namespaces Queries and other operations are then limited to one namespace, so different requests can search different subsets of your index. For example, let's say you work with news articles. You might want to define a namespace for indexing articles by content and another for indexing articles by title. Every index is made up of one or more namespaces, and every vector exists in exactly one namespace. Namespaces are uniquely identified by a namespace name. The default namespace is the empty string. Let's go ahead and add some random vectors to the Pinecone index. I'm generating a few random vectors with a dimension of 1536 using the random module. So import random and vectors equals and the list comprehension. Random.random. This will return a random float between 0 and 1 for underscore in range of 1536. This is one vector. And I want to generate 5 vectors. So I need a second list comprehension for v in range of 5. I have a list with 5 vectors with this dimension. It's a list of vectors. To insert a vector, we need the vector and its ID, which is a string. There are 5 vectors, and I'm creating a list with 5 elements, which are the IDs. IDs equals list of A, B, C, D, and D. 5 elements. I'm running the cell. The first step is to select the index. Index name equals LangChain Pinecone. And the index equals Pinecone.index of index name. To insert new vectors into the namespace of an index, use the upsert method. So index.upsert of vectors equals zip of IDs and vectors. Note that it's upsert and not insert. By calling the zip function, we connect the IDs and the vectors in a list of tuples. And an upsert is a single operation that can be used to insert a new value or update an existing value if it already exists. This can be useful for situations where you are not sure whether the value already exists. I'm running the code in this cell. And the method returned how many vectors it has inserted. To update a vector, you can use the same upsert method. You'll need to provide 2 arguments, the ID of the vector you want to update and the new value of the vector. For example, I'll update the vector with the ID C. So index.upsert of vectors equals and the list with a tuple as an argument. The first element of the tuple is the ID of the vector C, and the second argument, the new vector, the new value. For example, 0.3 times 1536. And I'm running the cell. Good. Let's go ahead and see how to fetch a vector by ID. I'm selecting the index if it's not already selected and calling the fetch method. So index equals Pinecone dot index of LangChain Pinecone. And the index.fetch of IDs equals and a list of IDs. For example, C and D. I am fetching two vectors. This is C, and we see the new value, the one that was updated, and this is D, the second vector. Now let's take a look at how to delete vectors by ID. So index.delete, the index was already selected, and the argument is IDs equals and a list of IDs, B and C. This method will delete two vectors. I'm running index.describe index stacks. Total vector count is 3. I have deleted 2 of them. If you fetch a vector that doesn't exist, you won't get an error, but an empty vector. Index.fetch IDs equals A and B. This is A, and I've got an empty vector for B. I've shown you how to delete vectors by ID, but if you want to delete all the vectors in the current index, call delete with delete all equals true. So index.delete of delete all equals true. It's deleting all the vectors in the index. Now, there are 0 vectors in the index. Now let's perform a query. I'm adding the random vectors to the Pinecone index again because I've just deleted all of the vectors. I'm creating the query vector. So queries equals random.random for underscore in range of 1536. This is just a vector, and I want a list of vectors. So I'll use a second list comprehension for v in range of 1. The query operation will retrieve the IDs of the most similar vectors in the namespace of the index along with their similarity scores. So index.query, the index was already selected, of queries equals queries, and the top k equals 3. It will return the top 3 most similar vectors. And I'm also adding include values equals false. I don't want to see the actual values. It will return the top 3 most similar matches to our query vectors. A, E, and D. And these are the scores. You see the scores in descending order. A is the most similar vector. If you want, you can have more than one vector in the query. I'm changing 1 to 2. I want to see the most similar 3 vectors to these 2 vectors in the query. I'm running the cell and this one again. These are the first matches for the first vector, and these are the second matches for the second vector. Great! In this video, you learned how to work with Pinecone. You learned about indexes, what they are, how to create and delete them, how to insert or update vectors to a namespace of an index, and how to fetch or delete vectors. You also learned to perform queries, to find the most similar vectors to one or more query vectors. We'll take a short break, and in the next video, we'll go over splitting and embedding text using LangChain. Welcome back. We are starting a series of lectures where we'll build on what we've learned so far and see the foundation of an AI application that can answer questions about the content of private documents. When dealing with very long pieces of text, it's necessary to split the text into chunks. You also want to keep semantically related pieces of text together. Let's look at an example. We'll load the data to be split from a text file, but you can load it from many other document types such as PDFs, CSV files, spreadsheets, SQL databases, and so on. In this example, we'll work with a text file. However, there are LangChain loaders that can be used to load data from almost any type of documents, including CSV, Evernote, file directories, Facebook chats, JSON files, PowerPoint, PDFs, and many more. There are also public service loaders from different services such as Project Gutenberg, Hacker News, Wikipedia, and YouTube. Additionally, there are proprietary service loaders for Amazon, Azure, Google, and others. In this example, I'll take the famous speech by Winston Churchill, "We shall fight on the beaches," which was delivered to the House of Commons of the Parliament of the United Kingdom in June 1940. This is the text file, and I'll split it into chunks. The default and recommended text splitter is called recursive character text splitter. I'm importing it. So from LangChain text splitter, import recursive character text splitter. By default, the characters it tries to split on are \n, \n, and y space. Now, I'm creating the text splitter object by calling the recursive character text splitter constructor. So text splitter equals recursive character text splitter. The first argument is the maximum size of your chunks as measured by the length function. We'll set a really small chunk size, which is around a line of text, just to show you how it works. However, you should experiment with different values to see which one works best. You'll normally use a higher value here. We'll talk more about chunking strategies for LLM applications later in the course. Also note that this is the maximum size of the chunk, but in reality, it can have a lower size. The next argument is a chunk overlap. This is the maximum overlap between chunks needed to maintain some continuity between them. And finally, the last argument, length function. It indicates how the length of chunks is calculated. The default is to just count the number of characters, but because we'll work with LLMs and LLMs use tokens, not characters, it's pretty common to pass a token counter here. I'm creating the chunks. Chunks equals text splitter dot create documents. And it takes as an argument a list of characters. Let's say Churchill speech. Of course, I have to open and read the contents of the file as a string in this variable. I'm doing it now. I'm opening the file as usual. So with open files Churchill speech.txt as f, and the Churchill speech equals f.read. This file is in a directory called files in the current one. you should use a correct relative or absolute path. I'm running the cell. Let's see the first chunks. Chunks of 0. This is the first one. This is the second chunk, the third chunk, and so on. Each chunk is approximately a line. If you want to see only the text, use chunks and an index, let's say 10, dot page content. And I've got the text only. Let's see how many chunks do I have. So now you have len of chunks. And the chunks. Good. There are 300 chunks. We'll be using OpenAI's text embedding 8.002, which has a cost. It's a good idea to calculate the embedding costs in advance to avoid any surprises. We'll use the tick token library for this. I've already shown you how to do this in the first part of the course, so I'll just copy and paste the code now. This is the function, and I'm calling it. So print embedding cost of chunks. So there are in total 5,820 tokens, and the embeddings will cost a fraction of a cent. It's really cheap. The next step is to import and instantiate OpenAI embeddings. I'm importing the required library. From LangChain embeddings, I'm importing OpenAI embeddings. And the embeddings equals, and I'm instantiating the object. If the API key is loaded in an environment variable, it is not necessary to pass it as an argument to this function. The OpenAI embeddings class can be used to embed text to vectors. For example, let's turn the first chunk into a vector of floating point numbers. So, vector equals embedding the object I've just created, dot embed query. And the argument will be a text. It can be any text. This is the embedding of string ABC. Let's see the embedding of the first chunk. So chunks of 0 dot page content. This is the embedding of the first chunk. Great! In this video, I've shown you how to split text and embed them into vectors using LangChain and OpenAI. We'll take a break, and in the next video, we'll move to Pinecone and see how to insert the embeddings into a Pinecone index. Welcome back. In this video, we'll embed each chunk of text into numeric vectors and insert them into a Pinecone index. I'm importing and initializing the Pinecone client. Import OS, import Pinecone, and from LangChain vector stores, I'm importing the Pinecone class. And I'm initializing the Pinecone client. So pinecone.init API key equals the environment variable os.environ.get of Pinecone API key. And the second argument, environment. os.environ.get, and the name of the variable. I'm running the cell. The next step is to create a Pinecone index. You can also use an existing index if you want. Note that if you are currently using the free plan, you are limited to one index and one project. And if you already have one, you will get an error if you try to create a second index. So it's a good idea to delete all existing indexes before creating a new one. Let's do this. Deleting all indexes. So I'm getting all the indexes in a list. I'm calling pinecone.listIndexes. Now I'm iterating over the list, deleting each index. So for I in indexes, pinecone.deleteIndex of I. And I'm also printing a message for the user. Deleting all indexes. At the moment, there's no index in Pinecone. I'm running the cell anyway, just to check that there's no error. Good. I'm creating a new index for these embeddings called Churchill speech. So index name equals Churchill speech. And if index name not in pinecone.listIndexes, so if the index does not already exist, I'm creating it. I'm printing a message for the user and creating the index. Pinecone.createIndex. The first argument is index name. The dimension, this will be the standard dimension of OpenAI's embeddings, 1536. Metric equals cosine. Okay, that's enough. And I'm printing done. Good. Note that index name must consist of lowercase alphanumeric characters or dashes, and must start and end with an alphanumeric character. I'm running the cell. It's creating the index, and I'm also refreshing the web interface of Pinecone. The index is initializing. Next, we will upload the vectors to Pinecone using LangChain. We will call pinecone.fromDocuments. So Pinecone from documents. This method takes 3 arguments: chunks, embeddings, and the index name. Index name equals index name. Let's take them one by one. Chunks is a list of text documents that have been obtained by calling the recursive character text splitter method. Here. These smaller chunks will be indexed in Pinecone to make it easier to search and retrieve relevant information later on. The embeddings object is an instance of the OpenAI embeddings class. By the way, let's call it embeddings. And I'm running these cells again. It is responsible for converting text data into embeddings using OpenAI's embedding model. These embeddings will be stored in the Pinecone index and used for similarity search. And the index name is a string representing the name of the Pinecone index. This name is used to identify the index in Pinecone's database and must already exist. This method also returns a vector store object initialized from documents and embeddings. So vector store. So, in a nutshell, this method, Pinecone from documents, processes the input documents, generates the embeddings using the provided OpenAI embeddings instance, and returns a new Pinecone vector store. The resulting vector store object can perform similarity searches and retrieve relevant documents based on user queries. I'm running the cell. We are waiting for it to finish. It's done. Let's take a look at the Pinecone dashboard. We can see that the index contains 300 vectors. These vectors were inserted by this code. We are done embedding the text into vectors and inserting them into a Pinecone index. Let's take a break. In the next video, I'll show you how to ask questions about the content of this custom document using a similarity search. So far, we've split the text into chunks and embedded them into vectors, which were then inserted into a Pinecone index. Now, let's see how to ask questions and do similarity searches. Here's how it works. The user defines a query. The query is embedded into a vector. A similarity search is performed in the vector database, and the text behind the most similar vectors is the answer to the user's question. I'm defining a query. So query equals. I've used the famous speech by Winston Churchill, "We shall fight on the beaches," and the query is, where should we fight? Now I'm extracting all the relevant chunks. So result equals vector store dot similarity search of query. And I'm printing the result. We see how it extracted the chunks relevant to the query. I can also iterate over the chunks and print only the chunk text. So for R in result, print R dot page content. And for readability, I'm adding 50 dashes after each chunk. I've got 4 chunks. These chunks represent the answer, but you can't give them to users like this. We need the answer in natural language. That's where an LLM comes in. We'll retrieve the most relevant chunks of text and feed them to the language model for the final answer. Let's do this. I'm importing the retrieval QA chain. From LangChain chains, import retrieval QA. I'm also importing chat OpenAI, the LLM. From LangChain chat models, import chat OpenAI. I'm defining the LLM. Chat OpenAI of model equals GPT 3.5 Turbo or GPT-4. And the temperature equals 1. Next, I'll expose this index in a retriever interface. The retriever interface is a generic interface that makes it easy to combine documents with language models. So retriever equals vector store as retriever of search type equals similarity as a string. And the second argument, search keywords equals, and the dictionary. The key is k and the value an integer, 3. K equals 3 means that it will return the 3 most similar chunks to the user's query. And finally, I'm creating a chain to answer questions. Chain equals retrieval QA dot from chain type of LLM equals LLM, chain type equals stuff, and the retriever equals retriever. The default chain type equals stuff uses all of the text from the documents in the prompt. I'm running the code in this cell. And I've got this warning because I have misspelled the word model. It's model, not mode. I'm running the cell again. There are no warnings. Let's ask some questions about the content of the document. Query, where should we fight? And the answer equals chain.run of query. I'm running the chain. I'm running it. And I'm printing the answer. And I've got the correct answer from the document in a natural language format. Let's ask something different. Query equals, who was the king of Belgium at that time? It's in the document. Perfect. This is the correct answer. And what about the French armies? Great. I am running the code again. If you ask it again, you'll get a different answer. Each answer is original. This is what the transformer technology means. Great! I hope you enjoyed this section. You've learned a lot. You've learned how to install LangChain and Pinecone and how to set up the environment. You've also learned about LLM models and how to call them from LangChain, prompt templates and how to create dynamic prompts, simple and sequential chains, and the LangChain agents. We then moved on to embeddings and vector stores. We covered Pinecone and saw how to manage Pinecone indexes. You saw how to insert vectors to the namespace of an index, query for the most similar vectors, and many more. At the end, we saw how to combine everything together to create the backbone of an OPL application. OPL stands for OpenAI, Pinecone, and LangChain. In the sections that follow, we'll develop hands-on projects in Python using OpenAI, LangChain, and Pinecone. This will be really fun. In this project, we will build a question answering system using the OPL stack. OPL stands for OpenAI, Pinecone, and LangChain. GPT models are great at answering questions, but only on topics they have been trained on. What if you want GPT to answer questions about topics it hasn't been trained on? For example, about recent events after September 2021 for GPT 3.5 or GPT 4, or about your non-public documents. GPT models can learn new knowledge in two ways: fine-tuning on a training set or model inputs. Fine-tuning on a training set is the most natural way to teach the model knowledge, but it can be time-consuming and expensive. It also builds long-term memory, which is not always necessary. Model inputs means inserting the knowledge into an input message. For example, we can send an entire book or PDF document to the model as an input message, and then we can start asking questions on topics found in the input message. This is a good way to build short-term memory for the model. When we have a large corpus of text, it can be difficult to use model inputs because each model is limited to a maximum number of tokens, which in most cases is around 4,000. We cannot simply send the text from a 500-page document to the model because this will exceed the maximum number of tokens that the model supports. The recommended approach is to use model inputs with embedded-based search. Embeddings are simple to implement and work especially well with questions. The pipeline is as follows. First, we prepare the search data, and we'll do that once per document. This means load the data into LangChain documents, split the documents into short and mostly self-contained sections called chunks, embed the chunks into numeric vectors using an embedding model such as OpenAI's text embedding ADA002, and save the chunks and the embeddings to a vector database such as Pinecone, Chroma, Milvus, or Quadrant. After we've prepared the document, we can do the search. Given a user query, generate an embedding for the question using the same embedding model. Using the questions embedding and the chunk embeddings from the first step, rank the vectors by similarity to the questions embedding using cosine similarity or Euclidean distance. The nearest vectors represent chunks similar to the question. The third step is to ask. You insert the question and the most relevant chunks obtained in step 2b here into a message to a GPT model. And the GPT model will return an answer. In this project, we'll build a complete question answering application on custom data that follows the pipeline I've just described. This technique is also called retrieval augmentation because we retrieve relevant information from an external knowledge base and give that information to our LLM. The external knowledge base is our window into the world beyond the LLM's training data. Because practice is more valuable than 1,000 words, let me show you the final version of the application. I have loaded, chunked, and embedded this PDF file on React. This document was published in March 2023 and was not included in the GPT-4 training data. By the way, in this context, React has nothing to do with the JavaScript framework used to build frontends. React is a general paradigm that combines reasoning and acting advances to enable language models to solve various language reasoning and decision-making tasks. Now, I want to ask questions about this document. It's like having someone in front of me who knows everything about React and can respond to any questions. The first question is, what is reasoning and acting in LLMs. And I've got the answer. I'm asking the second question. What is chain of thought? All these questions are from the document, from this document. And I've got a pretty good answer. And the last question, what is React prompting? Very well. I've got good answers to all my questions. Of course, instead of React, we can load a document about anything, a medical pathology, a treatment plan, legal documents, accounting documents, and more. Okay, we have a lot of work ahead, so let's get started building this application step by step. In this video, we will discuss how to load your private documents into LangChain. This is the first step in building the question answering application. The purpose of this project is to ask questions about the content of your custom or private data, which is stored in different formats such as pandas data frames, PDFs, CSV or JSON files, HTML or Office documents. LangChain provides with document loaders which load the data into documents. In the LangChain terminology, a document is a fancy way of saying some piece of text. These document loaders are aimed at making this task easy. There are two types of document loaders: transform loaders and public and proprietary dataset or service loaders. Transform loaders will transform the data from a specific format into the LangChain document format. This is what you will use most of the time for formats such as PDFs, CSV and JSON files, Office documents, and many more. You can see the entire list in the LangChain documentation here. The public dataset and service loaders are used to query and search for data on public websites such as Project Gutenberg, Hacker News, Wikipedia, and so on. The proprietary dataset and service loaders are used for private or proprietary services such as Azure, AWS S3, Google Cloud, Discord, Twitter, and many more. In this video, I will show you how to load your data from PDFs, which is a very common data format. In the next video, we will generalize it for other formats as well. I'm loading the environment variables used for authentication with OpenAI and Pinecone. To load PDF files, I'm going to install another library called PyPDF that is required. So pip install PyPDF. I want my code to be modular, so I'm defining a function. So df load document of file. The function will take as an argument a PDF file and return its text content. I'm importing the required libraries. From LangChain.document loaders, I'm importing the PyPDF loader class. By the way, the standard recommendation is to put import statements at the top of the file, here. However, there are cases when putting import statements inside the function is even better. This will prevent circular dependencies, and you will also benefit from a more reliable refactoring of your code. When you move a function from one module to another, you will know that the function will continue to work because it contains everything inside it. This function loads the PDFs using a library called PyPDF into an array of documents, where each document contains the page content and the metadata with a page number. I'm printing a message for the user. Loading and file. And the loader equals PyPDF loader of file. Note that it is also able to load online PDFs. Just pass a URL to a PDF to PyPDF loader. The next step is to call loader.load. This will return a list of LangChain documents, one document for each page, and I'm returning the data. The list. This will be the section for the running code. Let's test the function. I'm loading a local PDF file. In the current directory, there's a subdirectory called Files that contains a PDF called US Constitution. This one. I'm loading it. So data equals load document of, and the argument is files and US Constitution. The data was splitted by pages, and you can use indexes to display a specific page. For example, print data of 1. This is the second page because it starts from 0. Dot page content. I'm running the cell that contains the function and this one. And I've got the page. If you want to see the metadata of this document, use the metadata attribute. For example, data of 10 dot metadata. This is a dictionary. Let's check how many pages there are. You have len of data, pages in your data. There are 41 pages. And if you want to see how many characters are in one page, you can do print. There are curly braces, len of data of, let's say, 20, dot page content. Characters in the page. If you want to load remote PDFs, just pass the URL to the function as an argument. We are done. In this lecture, I showed you how to load PDFs into LangChain documents. We'll take a quick break, and in the next video, I'll show you how to load other document formats into LangChain. Bye bye. In the previous video, I showed you how to load PDF files into LangChain documents. However, your private, unstructured data isn't limited to PDF format. It can be found in various other formats such as Office documents, Google Docs, and more. Next, I'll demonstrate how to load these different document formats into LangChain. Let's change the load document function so that it accepts other formats as well. The function takes the file name to load as an argument. I'm gonna check the extension of the file, and based on its extension, I'll load it using the specific LangChain loader. I'm importing OS. I'm splitting the file name into name and extension. So name, extension equals os.path.splitText of file. You can print name and extension if you want to see their values. If the extension is .pdf, I'll use the existing code which loads PDF documents. So if extension equals .pdf, and I'm loading the data using PyPDF loader. I'm indenting these 3 lines of code. But if the extension is .docx, I'll use the code that logs Office documents. So elif extension equals .docx. I'm importing the required library from LangChain. Document loaders import docx to txt loader. This covers how to load Word documents into a document format that we can use later in the application. It is also necessary to install another Python module called docx to txt. I'm installing the package. pip install docx to txt -q, and I'm running the cell. Okay, it was installed, and I'm restarting the kernel to use the updated package. And I'm running the cell that logs the environment variables. Let's continue implementing the function. I'm printing a message for the user. It's the same message which says which file is loading, and the loader equals docx to txt loader of file. You'll add an elif branch for each document format you want to support. There are so many. Take a look here. When you are done with all the formats, add an else clause and print a message for the user, like this. Else, print, document format is not supported. And I'm returning none. Outside if elif else, I'm loading the data and returning it. Let's test the function. I'm running the cell, and here in the running code section, I'm gonna load a docx file that contains the novel The Great Gatsby by F. Scott Fitzgerald. It's in the files directory, this file. Data equals load document of files and The Great Gatsby .docx. This time, data is a list with a single element and the content is in the page underline content attribute. So print data of 0 dot page content. And I'm running it. It has displayed the document contents. If you take a look at LangChain document loaders in the documentation, you'll notice that in addition to transform loaders, there are also public and proprietary dataset or service loaders. We'll take a break, and in the next video, I'll show you how to load the data from public or private services. Bye bye. In the last 2 videos, we talked about transform loaders, which transform or load data from a specific format into the LangChain document format. In this case, the data was loaded from local files. usconstitution.pdf and the Great Gatsby.docx are local files. Now let's see how to load data from online services into LangChain. We don't deal with files, but with different protocols or APIs that connect to those services. Since the format and code differ for each service, I would create a unique function for each dataset or service loader that I want to support in my application. Let's do this for Wikipedia. I'm installing the Wikipedia module, which is a prerequisite. So pip install Wikipedia -q. And df load from Wikipedia. And the function will take two arguments, query and lang equals by default en. Query is free text which is used to find documents in Wikipedia, and lang is by default English and it is used to search in a specific language part of Wikipedia. I'm loading the Wikipedia loader. So from LangChain document loaders, import Wikipedia loader. And loader equals Wikipedia loader of query equals query, lang equals lang, and load max docs, let's say equals to. Load max docs can be used to limit the number of downloaded documents. You can use a hard-coded value or add a third argument to the function. Like this, load max docs equals to a default value, and here load max docs equals load max docs. I'm more flexible now. Data equals loader.load and return data. And that's it. I'm running the cell. And I'm loading something from Wikipedia in the LangChain document format. Data equals load from Wikipedia okay, it's load, it was a typo. Let's say GPT-4. I remind you that the training data for GPT-4 was cut off in September 2021. GPT-4 was launched in March 2023, so it was not included in the GPT-4 training data. Without loading the data from external sources, LLMs like GPT 3.5 Turbo or GPT-4 have no knowledge of it. And print data of 0 dot page content. And I'm running the cell. This is the data about GPT-4 downloaded from Wikipedia. If you want to see it in another language, just add a second argument with the language code. For example, DE from German, Deutsch or German. I'm running it again. Alright, in this lecture, I have shown you how to load data from an online service like Wikipedia. We will take a short break, and in the next video, we will discuss chunking documents. These will then be embedded into numeric vectors and uploaded to a vector store. Welcome back. Up until now, we've loaded our custom or private data into LangChain documents. The next step is to split or chunk the documents into smaller parts. In the context of building LLM-related applications, chunking is the process of breaking down large pieces of text into smaller segments. It's an essential technique that helps optimize the relevance of the content we get back from a vector database once we use the LLM to embed content. As you know, we need to first embed any content that we index in Pinecone. The main reason for chunking is to make sure that we are embedding a piece of content with as little noise as possible while still keeping it semantically relevant. For example, in a semantic search, we index a corpus of documents. Each document contains valuable information on a specific topic. By applying an effective chunking strategy, we can make sure that our search results accurately capture the essence of the user's query. If our chunks are too small or too large, it may lead to imprecise search results or missed opportunities to surface relevant content. As a rule of thumb, if a chunk of text makes sense without the surrounding context to a human, it will make sense to the language model as well. Therefore, finding the optimal chunk size for the documents in the corpus is crucial to ensure that the search results are accurate and relevant. I'm defining a function called chunk data. df chunk data of data. LangChain provides many text splitters, but recursive character text splitter is the recommended one for generic text. I'm importing it from LangChain text splitter, import recursive character text splitter. By default, the characters it tries to split on are double \n, \n, and whitespace. I have already explained to you in the previous section how recursive character text splitter works, and now I'm just writing the code. So text splitter equals recursive character text splitter of chunk size equals 256 and chunk overlap 0. When a sentence is embedded, the resulting vector focuses on the sentence's specific meaning. The comparison would naturally be done on that level when compared to other sentence embeddings. This also implies that embedding may miss out a broader contextual information found in a paragraph. When a full paragraph or document is embedded, the embedding process considers both the overall context and the relationships between the sentences and the phrases within the text. This can result in a more comprehensive vector representation that captures the broader meaning of the text. To be flexible, I'll add a second argument with a default value for the chunk size instead of this hard-coded value. So chunk size equals 256. And here chunk size equals chunk size, the function's parameter. It's better now. And chunks equals text splitter dot split documents of data. It returns a list of documents. Use create documents instead of split documents when it's not already splitted in pages. This depends on how you have loaded the data. And I'm returning the chunks. I'm running the cell. Let's test it in the running code part. Okay, I'm gonna load the US Constitution. I'm commenting out the other code. I'm running this cell. I'm loading it, and I'm running chunks equals chunk data of data. Data was returned by load document. Let's see how many chunks do I have. Print len of chunks. And I'm running it. There are 190 chunks. And if you want to see one chunk of data, you can do print chunks of 10 dot page content. This is the chunk at index 10. Good. We'll be using OpenAI's text embedding ADA002, which has a cost. It's prudent to calculate the embedding costs in advance to avoid any surprises. We'll utilize the tick token library for this. As I've already shown you how to do this in the first part of the course, I'll be simply copy-pasting the code. I'm running the cell and checking the cost. So print embedding cost of chunks. Okay, it's really cheap. After chunking the document, the next step is to embed the chunks and upload them to a vector database like Pinecone. We'll take a break, and in the next video, we'll discuss embedding and uploading to a vector database. We've loaded the data into LangChain documents, and split them into smaller chunks. Next, we'll embed the chunks and upload both the chunks and the embeddings to a vector database like Pinecone for fast retrieval and similarity search. I'm defining a function called insert or fetch embeddings. This function will embed the chunks and add both the chunks and the embeddings into a Pinecone index. If the index already exists, the function will load the embeddings from that index. I'm importing the required modules. Import Pinecone. From LangChain vector stores, import Pinecone. Pay attention, there are two Pinecone names. One is the Pinecone library written with a lowercase p, and the other one, the Pinecone class from LangChain vector stores written with a capital P. And from LangChain embeddings OpenAI, import OpenAI embeddings. The OpenAI embeddings class is used to embed text into vectors. So embeddings equals OpenAI embeddings. If the OpenAI API key is loaded as an environment variable, it is not necessary to specify it as an argument. And I'm initializing Pinecone. To do this, we'll need a Pinecone API key. We covered this in the last section where we discussed Pinecone for the first time. So, Pinecone init of API key equals os.environ.get of Pinecone API key. And environment equals os.environ.get of Pinecone env. If you already have an index, you can load the embeddings like this. By the way, this function will have the Pinecone index name as a parameter. If index name in Pinecone dot list indexes, I'm loading the embeddings. So vector store equals Pinecone dot from existing index. Index name and embeddings. And I'm also printing a message for the user. Index name already exists. Loading embeddings. But if the index does not exist, create the index and insert the embeddings. So else, I'm printing a message for the user, creating index name and embeddings. And Pinecone dot create index of index name, dimension 1536, and metric cosine. Good. And the vector store equals Pinecone. Note that it's with a capital P. It's a class from LangChain vector stores. Dot from documents of chunks, embeddings, this object, and the index name. And I'm returning the vector store. Okay, and here it's insert or fetch embeddings. I'll also create a function that deletes a Pinecone index or all the indexes. So df delete Pinecone index, and the index name equals by default all. Because the Pinecone free tier supports only one index, it could be necessary to delete the existing index frequently. I'm importing Pinecone, initializing it, and testing if index name equals all. If it is equal to all, I'm deleting all indexes. So if index name equals all, I'm taking the indexes in a list equals pinecone.listIndexes. I'm printing a message for the user saying that I'll delete all indexes. So deleting all indexes. Now I'll iterate over the list and delete each index. For index in indexes, pinecone.deleteIndex of index. And I'm printing OK or done. Now the else branch. If the user calls the function with an index name, I'll delete only that index. So print deleting index name in curly braces, and the line of code that deletes that index. Pinecone delete index of index name. Okay, let's test the function. I'm running the cell and moving into the running code part of the notebook. Here. To make sure that there are no Pinecone indexes, I'll remove all indexes first. I am using the Pinecone free tier and I want to avoid getting an error when I try to create a new index. So delete Pinecone index. It's deleting the indexes. Unfortunately, there's a typo. Let's see what's all about. Of course, it's a spelling error. It's init, not ini. Init. I'm running it, and probably it's ini here too. I copy pasted this line of code. I'm running it again. Okay. There's no Pinecone index. Let's check it on the Pinecone website too. Next, I'll create an index, embed the chunks, and upload both the chunks and the embeddings to Pinecone. So index name equals ask a document. And the vector store equals insert or fetch embeddings of index name. I'm running the cell. At this moment, it's creating the index. I'm refreshing the page, and we can see how it's initializing the index. Good. It may take a few minutes, so I'm pausing the recording. Okay, it's done, but I've got an error. It's in insert or fetch embeddings. Here. Let's solve it. I'm gonna use a keyword argument for the index name. It's possible that it is not the third argument. So index name equals index name. Index name on the left hand side of the equal sign is the method argument, and the index name on the left hand side is my function's argument. I'm running this cell again, deleting all the Pinecone indexes and create the index and the embeddings again. We are waiting until it's done. I'm pausing the recording till that moment. It's done. I'll check now the index and the vectors on Pinecone. We can see that the index contains 190 vectors. We have loaded the data into LangChain documents, split the documents into chunks, embedded the chunks, and uploaded them to the Pinecone index. We've done a lot of work. In the next video, we'll start asking questions and getting answers based on similarity search. We need the answer in natural language, so we'll use a large language model to get it. I'm creating a new function, df ask and get answer. The function will have two parameters, the vector store and the question or the query. First, we'll retrieve the most relevant chunks of text from our vector database. Then, we'll feed those chunks to the LLM to get the final answer. In the previous section, I've already explained the code, and now I'm just copy-pasting it here. This is the notebook from the previous section. Okay, this is the code. I'm copy-pasting it in the function. And I am indenting it correctly. I'm also running the chain. Answer equals chain.run of q and return answer. I'm running the cell. Let's test it. So q equals, what is the whole document about? And the answer equals ask and get answer of vector store and q. And of course, print answer. I'm running the cell. And it says that the document is about the US Constitution. Very well. What I'll do next is create a loop so that the user can send questions to the application continuously. Import time, I equals 1. This is a counter to display the question number and the message. Write quit or exit to quit. And now the while loop. So while true, colon. This will be an infinite loop and it will stop when the user enters quit or exit. So q equals input question and hash and I in curly braces. And of course, this is an F string. Like this. I equals I plus 1. I'm incrementing the counter. I'm checking if q equals exit or quit. And if it's the case, I'm breaking out. So if q dot lower in quit and exit. If it's the case, I'm printing a message, quitting, bye-bye. Time.sleep of 2. I'm pausing for 2 seconds so that the user has enough time to read the message, and I'm breaking out of the while loop. If q is not quit or exit, I'm asking the question. Answer equals ask and get answer of vector store and q. And I'm printing the answer. So answer, colon, and the answer in curly braces. And I'm adding a new line before the answer. This is for a better readability. And also 50 dashes after each answer. \n dash times 50 and another \n at the end. Okay, this is just for readability, for a better readability. I have loaded the US Constitution, so let's ask questions about the US Constitution. We have in front of us the best expert on the US Constitution. I'm running the cell. The first question. What is the first amendment of the US Constitution? Let's see what it will answer. Very good. I've got a very good answer. Okay, another question. Explain the concept of federalism as it is presented in the US Constitution. And I've got the answer. It's about federalism. Now describe the Bill of Rights. Very good. Note that you can send more than one question to the LLM at the same time. For example, Q1, colon. How does the Constitution address the issue of presidential succession? And Q2, the second question, describe the Bill of Rights and answer both questions. And I'm hitting enter. Depending on how busy the OpenAI's backend is, you'll wait a few seconds or more. I've got the answers of both questions, A1 and A2. You can get accurate answers from the LLM on any topic, even if that data wasn't included in the training. You can also use other languages. I'm quitting. Now, I'm loading another document. This time, I'll load a Wikipedia page in Romanian, my native language. I use the Pinecone free tier and I will delete the existing index because only one index is permitted. So delete Pinecone index and I'm running the code. Good. It's deleting all indexes. And data equals load from Wikipedia, ChatGPT is the term, and RO the language. And chunks equals chunk data of data, and the index name equals ChatGPT, vector store equals insert or fetch embeddings of index name, and that's it. I'm running it. It will get the data from Wikipedia, chunk it, create an index, embed the chunks, and insert both the chunks and the embeddings into a Pinecone index. It's creating and initializing the new index, ChatGPT. I am preparing the first question in Romanian. Q equals, what is ChatGPT? I'm waiting for it to finish, and the answer equals ask and get answer of vector store and Q. And I'm printing the answer. It's still running, so I'm waiting a few more seconds. It's done. If you get an error, you can run the code again because Pinecone is overloaded sometimes. I'm running this cell. And I've got a pretty good answer in Romanian. When was GPT-4 launched? Very good. And the last question, what is Instruct GPT? Of course, I'm writing all questions in Romanian. And I've got very good answers for each question. The LLM was able to answer a question from a new document that was not included in its training data. We have a very useful application that can be used for real businesses. However, it lacks memory or chat history. We'll take a break, and in the next lecture, I'll show you how to add memory or chat history to this application. Welcome back. Our LLM application can answer questions on private or custom data, but it doesn't remember previous questions or answers. For example, I loaded the US Constitution into LangChain, chunked it, and embedded the chunks in the Pinecone index. Now, I'm asking a few questions. I'm running the while loop. How many amendments are in the US Constitution? It correctly answered 27. Now, I'm asking the application multiply that number by 2. And it said, I am sorry, but I don't have a number to multiply by 2. That's because the application didn't save the previous question and answer. It doesn't have a chat history. Sometimes it is necessary to save the context, and I'll show you how to add memory to our application. I'm creating a new function for this. df ask with memory. And the function will have 3 parameters. Vector store, Q or question, and the chat history. By default, this is an empty list. Instead of using retrieval QA, I'll import and use another chain called conversational retrieval chain. From LangChain chains, import conversational retrieval chain. This is built on retrieval QA and provides chat history. I'm also importing chat OpenAI and defining the LLM. LLM equals chat OpenAI of temperature equals 1. By default, it uses ChatGPT 3.5 Turbo. Now I'm creating the retriever interface as in the last example. In fact, I'm copy-pasting that line of code. I'm creating the chain object by passing the LLM and the retriever to the conversational retrieval chain dot from LLM. So conversational retriever chain equals conversational retrieval chain dot from LLM of LLM and retriever. And I'm running the chain, passing the question and the chat history. Result equals CRC of and the dictionary. question is the first key, and the Q, the function's parameter, X value. In fact, I'll use question here too. And chat history, colon, chat history, the function's parameter. I'm appending the question and the answer to the chat history list. This will allow me to keep track of all the questions and answers that have been exchanged during the chat. So chat history, dot append of, and I'm adding it as a tuple. Question, comma, result of, answer. And finally, I'm returning the result and the chat history. Okay, I'm running the cell. And the code in this cell was executed. Let's test the new function. I'm creating an empty list for the chat history. Chat history equals empty list. And I'll ask the first question. Question equals, how many amendments are in the US Constitution? And the result, comma, chat history equals ask with memory of vector store, question, and chat history. And I'm printing the result and the chat history. So print result of answer and print chat history. I'm running this cell. Great. I've got the correct answer, and I also see the chat history, the question, and its answer. Let's send a second query. Question equals multiply that number by 2. Notice that I didn't specify what number to multiply. It has to deduce that from the context. And the result, comma, chat history equals ask with memory, vector store, question, and chat history. And I'm printing the answer and the chat history. I'm running the cell. And I've got the right answer. You can also see the chain of thoughts. Note that if you have a free OpenAI account, you are currently limited to 3 requests per minute. If you get a rate limit error, just wait a few more seconds before sending the next question. Alternatively, add a credit card under billing. Great! We are at the end. We now have a working question answering application that can answer any question about the content of custom or private documents. It uses OpenAI, Pinecone, and LangChain to process large amounts of text data quickly and efficiently. We will probably add a fancy web interface and use it in production. We might even sell it to other businesses. Here are some of the benefits of using such an application. Increased productivity. Employees can save time by quickly finding the information they need without having to search through documents or ask colleagues for help. Improved accuracy. Employees can be confident that the information they are using is accurate, as the application is able to understand complex questions and provide accurate answers. And reduced costs. Businesses can save money by reducing the need to hire additional staff to answer questions or by outsourcing the task to a third party. I believe that any business that deals with large amounts of text data could benefit from using a question answering application. Here are some additional ideas for developing the application. Add support for more languages, for more document formats, and for more question types. The application could be made to support more question types such as open-ended questions, multiple choice questions, or fill-in-the-blank questions. In conclusion, LangChain is a powerful tool that can process large amounts of text data quickly and efficiently, while Pinecone is a scalable vector database that can store and index large amounts of unstructured text data. Hello guys! In the last project, we developed a question answering application powered by a large language model. We went through it step by step, line by line, and now it's time to take it to the next level. To build this application, we used the LangChain framework, a vector store like Pinecone or Chroma, and OpenAI. It was an exciting journey. We relied on Jupyter Notebook, a great tool for code writing, prototyping, and experimentation. However, it's not suitable for production or end-user use. If we want our application to be accessible to everyone, not just developers, we need to create a web app or a front-end for it. There's where Streamlit comes in. Streamlit is an amazing open-source Python library that simplifies the creation and sharing of custom web apps and front-ends for machine learning and data science. With Streamlit, we can give our application a user-friendly interface and make it available to a wider audience. Completing this project requires some experience with Streamlit. But don't worry if you are new to it, I've got you covered. I included a Streamlit section specifically designed for beginners, so you can learn along the way. Take a look at it for a refresher. Are you ready? Let's dive right in and start this exciting project. We'll write the code in PyCharm, but any other IDE like Visual Studio Code is also a good option. We won't use Jupyter Notebook because creating a web app inside another web app can be problematic. I recommend setting up a virtual environment to ensure that the dependencies needed for this project don't impact any other Python projects you are working on. I'm installing the libraries that we need. In the current directory, there's a file called requirements.txt that contains the name of the libraries. For this project, we'll opt for Chroma as our vector database instead of Pinecone. Chroma is more suitable for small to medium-sized projects. If you are dealing with only a few files, each containing tens to hundreds of pages, you can utilize an in-memory vector store. You won't necessarily need dedicated hosting. Additionally, there's no requirement to work with indexes and namespaces, which can also save you time and effort. However, feel free to choose Pinecone if you prefer it. You already have all the knowledge I shared with you in the previous section. In the terminal, I'm moving to the project's directory, LLM question answering app, and I'm running pip install -r requirements.txt. It's installing all these libraries. If you are using Windows, it is possible to encounter an error related to a dependency extension of ChromaDB called hnswlib. This is the error. If you do not encounter this error, or if you prefer to use another vector store like Pinecone, you can ignore the solution I will provide and the rest of this video. This error specifically occurs on Windows. This is how I solved it. First, I visited this link, visualstudio.microsoft.com/visualcpp build tools. This one. I downloaded and installed the build tools. Then I searched for and opened Visual Studio Installer. This app. I clicked Modify and then navigated to individual components. Here, I found these two components, MSVC V143 and Windows 11 SDK. And I installed them. You can also search for the components using the search bar. Finally, I restarted Windows and ran pip install -r requirements again. You can also take a look at this Stack Overflow thread where exactly this error and its solution are discussed. That's it. Thank you, and I'll see you in a second. I'm importing the required libraries. Import Streamlit as st. And from LangChain.embeddings.openai, import OpenAI embeddings. And from LangChain vector stores, import Chroma. I'll use Chroma as our vector database. Chroma is an AI-native open source vector database that can run in various modes: in memory with persistence, or in a Docker container. We'll keep the vector database in memory, and it can be used by the Python interpreter in a script or in Jupyter Notebook. I'm also importing OS. Now, I'll start pasting the code from Jupyter Notebook into this Python script. I've already explained that in detail, and now I'll just use the code or extend it if necessary. I'm pasting the load document function. This function can load PDF and docx files in the LangChain document format. I'll add the code that loads text files as well. I am adding an elif branch. So elif extension == I'm importing the text loader class from LangChain.documentLoaders. Import text loader. And loader equals text loader of file. And that's it. Now we can load text files as well. I'm copying and pasting the chunk data function definition. This one. And I'm adding a new parameter, chunk overlap. Chunk overlap equals 20. And the chunk overlap equals chunk overlap. It's not recommended to use hard-coded values because you have no flexibility at all. The next step is to define a function called createEmbeddings. This function will take the chunks as an argument, embed them, and return a Chroma vector store. So def createEmbeddings. It has one parameter, chunks. Embeddings equals OpenAI embeddings. I'm initializing an object of this class. And the vector store equals Chroma dot from documents of chunks and embeddings. And I'm returning the vector store. In the next step, I'll copy and paste the ask and get answer function. This one. And I'm also adding a third argument, k, for search keywords. This one. This argument will have a default value, let's say 3. And here I'll use k. This is the function's argument. When making a similarity search, it will return the k most similar chunks of data to our question. The large language model, GPT-4 for example, will take these k chunks and create the answer in natural language. If you want a more elaborate answer, increase k. Note that the higher the k value, the higher the price you'll pay because you'll use more tokens. We'll be using OpenAI's text embedding ADA 002, which has a cost. It's recommended to calculate the embedding costs in advance to avoid any surprises. We'll utilize the tick token library for this. I have already shown you how to do this in a previous section, and now I'll be simply copy-pasting the function definition. Instead of printing the total number of tokens and the embedding cost, I will return them. So return total tokens and the price. The parentheses are not required. I'm also changing the name of the function to calculate embedding cost. These are all the functions we'll need. We are taking a break, and in the next lecture, we'll start creating the layout. Now, I'll add the application entry point. If dunder name equals dunder main. I'm authenticating to OpenAI using the generated API key. I suppose you have already signed up for a new account on OpenAI and generated the API key. This key resides in a .env file in the current directory, here. This is the key. You should always keep the keys secure. In my case, I'll rotate or generate a new key after recording this video. I'm using .env. I've explained that in detail in the previous section. You can authenticate using this method, or you can create a text input and the user will paste the API key. I'll show you this method as well. Now, just for a nicer design, I'm adding an image and a subheader. The image is in the current directory. This is the image. So st.image and the file name img.png and the st.subheader of and the string LLM question answering application. I will organize some important widgets in a left panel sidebar with st.sidebar. This way, I save space and the user can focus on the main page content. So with st.sidebar, and I'm creating the text input for the OpenAI API key. You can load it from .env using python.env, as we've done in the previous section, or the user will paste the key in the text input. Maybe they don't have access to the .env file. API underline key equals st.textInput of OpenAI API key. And the second argument, type equals password. Type password means that it will display asterisks instead of the actual key. This is a security measure. And if API key, if the user entered the key and hit enter, I'm loading it in an environment variable. os.environ of OpenAI API key in capitals. Equals API key. The next widget will be the file uploader. So uploaded file equals st.file uploader of a string, upload a file, and type equals, and the list PDF, docx, and txt. I will allow only these types. Next, I'll add some optional widgets for some advanced settings. I'll add a number input for the chunk size and another one for k. Chunk size equals st.number input. The label will be chunk size. Mean value equals 100. Max value 2048. And the default value will be 512. And the k equals st.number input. K the label. Mean value 1. Max value 10 or 20. It doesn't matter. And the default value will be 3. Next, I'll add a button called Add Data. When the user clicks this button, the file is chunked and the chunks are embedded in numeric vectors and also saved in the Chroma vector store. So add underline data equals st.button of add data, the label, and that's it. Let's test the app. I'm running in the terminal, Streamlit, run, and the name of the script. Chat with documents. And it's starting. Very good. This is the sidebar. And this is the main area of the page. We have a text input for the API key, the upload file widget, the number input for chunk size, and another one for k, and the add data button. Very well. We are taking a break. In the next video, we'll read chunk and embed data when the user clicks add data. Let's go ahead and process the uploaded file. If uploaded file and add data, if the user uploaded a file and clicked add data, I'm creating a spinner, which is a widget that temporarily displays a message while executing a block of code. So with st.spinner and the message, reading, chunking, and embedding file. The uploaded file is contained in a bytes IO buffer in Python memory, in RAM, not on disk. I'm copying the file, which is in memory, to the disk locally. Bytes data equals uploaded file.read. It reads the content of the file in binary. And file name equals os.path.join, the current directory, /, and the uploaded file.name. I'm copying the file to the current directory, but you can copy it to any other directory. If you want to copy the file to a different directory, you can do so specifying the path to the directory in os.path.join. Here. And with open file name and WB, I'm opening the file in binary and write mode as f.write of bytes data. Good. Now I'm loading the document by calling the load document function. This one. Data equals load document of file name. The next step is to chunk it. I'll split the data into chunks by calling chunk data. This function. Chunks equals chunk data of data and chunk size equals chunk size. Chunk size is the value of the input text widget of this one. Just for debugging purposes, I'm displaying both the chunk size and the number of chunks. st.write chunk size colon and the chunk size in curly braces. This is an F string. And the chunks len of chunks. I'm also displaying the embedding cost. Tokens, comma, embedding cost equals calculate embedding cost of chunks. And st.write of f and the string. Embedding cost, the $, and in curly braces embedding cost. And I'm displaying it with 4 decimal points. Next, I'll embed the chunks. I'm calling create embeddings. Vector store equals create embeddings of chunks. The function I've created earlier. I need to save the vector store between page reloads because I don't want to read and chunk the file and embed the chunks each time the user interacts with a widget. I'm saving the chroma vector store in the session state as vs from vector store. So st.sessionState.vs equals vector store. Finally, I'm displaying a success message. st.success file uploaded, chunked, and embedded successfully. I'm testing the app. This is the interface. I am clicking Browse Files, selecting a file, for example, Churchill speech. Okay. There's a small error. I forgot a colon after with st.spinner. Here. No problem, I'm adding it. Okay. And I'm reloading the page. Rerun. I'm clicking Add Data. This is the message, the chunk size, the number of chunks, and the embedding cost. And finally, the success message. Okay, I am changing the chunk size to 200 and the K to 5. And I'm clicking Add Data. Now the chunk size is 200. There are 140 chunks, and this is the embedding cost. It is working as expected. We are done with the sidebar. We are taking a break, and in the next video, we'll deal with the main part of the web page. We are done with the sidebar, and we'll deal with the main part of the web page where we'll display the asked questions and the received answers. I'll display a text input for the user's question. This will be displayed outside the sidebar in the main part of the web page. Use the correct indentation. I'll write the code at the same indentation level as with sidebar. Q equals st.textInput. The label will be ask a question about the content of your file. If the user entered a question and if the vector store already exists in the session state, I'm loading the vector store from the session state into a variable. So if vs the name of the key in the session state in st.session_state, vector store equals st.session_state.vs. This condition is necessary because the user could ask a question without first loading the file, splitting it into chunks, and embedding the chunks. Now, just for debugging purposes, I'll display the value of k. st.write k colon and k in curly braces. This is the number of the most similar chunks that the LLM will use as input for the final answer. The k parameter controls how many of the most similar chunks the LLM will use for the final answer. A higher k value will result in a more accurate answer, but it will also take longer to generate the answer. You can comment out this line when everything works as expected. I have the user's question and the vector store with the embeddings of the document, and I can call the ask and get answer function. So answer equals ask and get answer of vector store q, the question, and k. I will display the answer in the text area below. So st.textArea LLM answer colon and the value equals answer. Let's test the app up to this point. I'm loading the speech of Churchill. We shall fight on the beaches. It's the same document we used in the previous sections too. Where should we fight? K equals 2, and this is the answer. We shall fight on the beaches, in the landing grounds, in the fields, in France, on the seas and oceans, and in the air. Very good answer. What about France? And I've got the answer. Let me show you how important the chunk size and k are. I am setting the chunk size to 100 and k equals 2, and I'm clicking Add Data. The question will be, who is the King of Belgium? And it says that the context I provided does not mention the name of the King of Belgium. Now, I'm increasing the chunk size to 256 and k to 3. I'm clicking Add Data and asking the question again. Okay, it doesn't know who's the King of Belgium. Now I'm increasing k to 5. It will use 5 chunks to assemble the final answer. And I've got the correct answer. The King of Belgium at the time of the mentioned events is King Leopold. The application works great, but we don't save the chat history anywhere. We can see only the last question and answer. We are taking a break, and in the next video, we'll add this feature, saving and displaying the entire chat history. Welcome back. We have a working LLM-based question answering app with a nice frontend. However, there's a way to improve it. For example, at this moment, we can only see the last question and answer. In this video, we'll save each question and answer in the session state history and display them all. I'm adding a divider to separate the current answer from the previous ones. st.divider. I'm creating a key in the session state called history. The corresponding value will be all the previous questions and answers. So if history not in st.sessionState, st.sessionState.history. I'm creating the key equals empty string. I'm concatenating the current question with its answer, like this. Let's say value equals an f string q colon, small q in curly braces, the question, backslash n, this is a new line, a colon, and answer. These are the current question and answer. I'm also adding this value before the existing history. I want the current question and answer to be displayed first. So st.sessionState.history equals an f string, the value, the current question and answer, backslash n. I am adding 100 dashes for readability, another backslash n, and the history, st.sessionState.history. Now I'm taking the chat history from the session state into a variable. This variable will be used to display the chat history in a text area. st.textArea of label equals chat history, value equals age, key equals history, history as a string, and height equals 400. Key equals history means that we'll store the value of this widget in the session state as the value of a key named history. Remember that the session state is like a dictionary. Let's test the application. I'm rerunning it. I'm loading another file. I'm loading the US Constitution. And I'm clicking Add Data. Who delivered the speech? The context does not provide information about who delivered the speech. Okay. Let's ask another question. What is the document about? The document in question is the United States Constitution. Very well. And we also see the chat history. All the questions and the answers. What you could also do is add a question to the history only if it doesn't already exist. What is the First Amendment? And I've got the answer. We can see it in the chat history as well. Describe the Bill of Rights. Very good. The Bill of Rights is the collective name given to the first 10 amendments of the United States Constitution. You can also ask short questions that seem incomplete or are not 100% grammatically correct. The AI model will understand that perfectly. I'm asking, number of senators. There's no verb, and I've also abbreviated the word number as NO dot. And I've got the correct answer. The number of senators in the United States is 2 for each state. You can see that the LLM understood that I wanted to find out the number of senators as stated in the US Constitution. The last thing I want to do is to clear the history from the Streamlit session state when the user loads a new document or when they change the chunk size or key. Right now, the chat history remains in the text area even after I load a new file, change the chunk size or key. Welcome back. The last thing I want to do is to clear the history from the Streamlit session state when the user loads a new document or when they change the chunk size or key. Essentially, I want to start it from scratch because it's a different document. To delete the chat history, I'll use a Streamlit callback function. I want to remind you that a callback is a function that gets triggered when the user interacts with a widget. Usually, when you interact with a widget, like pressing a button or writing in a text input and hitting enter, the entire Python script is rerun from top to bottom. However, if you attach a callback function to the widget, Streamlit will run this function when it detects a change in the widget state before rerunning the script as usual. This is an extra task for Streamlit before rerunning the script. We utilize callbacks via the onChange or onClick parameters of the widget. I am adding the onChange argument to the chunk size and k widgets. To these two widgets, chunk size and k. OnChange equals clear history. And the same for the k widget. OnChange equals clear history. Clear history is the name of the callback function. I'm also attaching the callback function to the add data button. For buttons, use onClick instead of onChange. OnClick equals clear history. Now I'm defining the clear history function. def clear history. If history in st.session state, so if the history key exists, I'm deleting it. Del st.session state of history, and that's it. Let's test it and see how the history is cleared when the user loads a new document or changes the chunk size or key. And one more thing, indent this piece of code so that it is inside the if statement. Like this. We'll do all of these things if we have the vector store. I'm rerunning the app. And I'm loading another file. I'm loading the Great Gatsby. I'm changing the chunk size to 512 and the k will be 4. I'm clicking add data. It's reading, chunking and embedding the file. There are in total 611 chunks and the embedding cost is 2 cents. Very well. And I'm asking a question. Who is Gatsby? Very good. What does he do? Very good. This is the answer, and this is the chat history. Now, I'm changing the chunk size. The chat history should be cleared. I'm clicking Add Data, and I am waiting. Very good. The chat history was cleared. Who wrote the novel? Very good. I've got the correct answer. Okay. We are done. I hope you enjoyed it. In this project, I showed you how to create a nice and modern web frontend for your LLM-based question answering app using Streamlit. Now you can present your app to your customers or even use it in production. Of course, this is just a prototype. You can add some new features, change the layout, or add your own style. In this project, we'll build a summarization application from scratch using LangChain and OpenAI. This is a valuable tool for anyone who needs to summarize large amounts of text, such as students, researchers, and business professionals. Imagine being able to feed a document with hundreds of pages into an application and have it generate a customized summary for you, complete with an introduction paragraph, bullet points with the main ideas, and the conclusion. Another common use case for summarization applications is to create summaries of conversations. For example, a customer service representative could use a summarization application to create a summary of a conversation with a customer. This would allow the representative to quickly review the conversation and identify any important information. The summarization method and chain you choose will depend on the length of the text you want to summarize. In this project, we'll cover basic prompts, prompt templates, 3 different chain types, stuff, MapReduce, and refine, and the LangChain agents. We'll also go through some methods of summarization, from summarizing a few paragraphs to summarizing entire books or custom length text, such as law or medical documents. By the end of this section, you'll be an expert in building summarization applications with LangChain and OpenAI. Welcome back. We'll start with the basics with the simplest method of summarization. Basic prompt. If you have a few sentences or paragraphs of text and you want to summarize it in one shot, you can use a simple prompt and insert your text into the prompt. This method is not flexible or scalable because it is limited to the model context length, which is around 4096 tokens. The pros of this method are that it only makes a single call to the LLM, and when generating text, the LLM has access to all of the data at once. Let's see how to do it. I have already loaded the API keys as environment variables. In the current directory, there's a .env file that contains the API keys. The OpenAI API key, the Pinecone API key, and the Pinecone environment. And the load.env loads the API keys as environment variables. I'm gonna use a chat model such as GPT 3.5 Turbo or GPT-4. I'm importing the chat OpenAI library and the schema which are required. From LangChain schema, import AI message, human message, and the system message. I'm pasting a text about a new programming language called Mojo that is a Python superset and optimized for AI and LLM applications. Mojo combines the usability of Python with the performance of C. This is the text I want to summarize. Providing instructions to the LLM is one of the most important part. I'm creating the messages list and system message of content equals and the system message prompt. You are an expert copywriter with expertise in summarizing documents. And the human message. Content equals, this is the prompt, the instructions. Please provide a short and concise summary of the following text. \n and the text colon and the text in curly braces. This is an F string. I'm defining the LLM. Chat OpenAI. It's not completing the name of the class because I didn't execute this cell. Okay. Temperature equals 0 and the model name equals GPT 3.5 Turbo. You can use GPT 3.5 Turbo or GPT-4. I'm using GPT 3.5 Turbo because it's much cheaper. And I'll use a temperature of 0 because I don't want any hallucinations in the summary. Let's see how many tokens has our prompt. LLM.get num tokens of text. Note that this is only a rough estimate. The total number of tokens will be a little bit higher because this number doesn't include the overhead of the messages list or the response of the model. And I'm running the LLM with the messages as an argument. The messages list. So summary output equals LLM of messages. It's running. It's summarizing the text. And I'm printing the summary. Let's see it. Print summary output dot content. I've got a short and concise summary of that text. This is good only if you have a small amount of text to summarize. In the next video, we'll add a dynamic part to the prompt and we'll summarize using prompt templates. In the last video, we saw how to summarize a few paragraphs using a basic prompt. Let's go ahead and use the same method, this time with a prompt template. I want to benefit from the dynamic prompts offered by LangChain. So, summarizing using prompt templates. Also, note that this method is restricted to summarizing text that together with the summary has a length lower than the model's maximum allowed number of tokens. I'm importing a prompt template and LLM-chain. From LangChain, import prompt template. And from LangChain chains, import LLM-chain. I'm creating the template. This is a multi-string line. So write a concise and short summary of the following text. Text, colon, and the text in curly braces. You can also write it in backticks. And translate the summary to language. There are two dynamic parts in the prompt, text and language. And the prompt. Prompt template of input variables equals and a list with the variables, text and language, and the template equals template. Let's check how many tokens are in the prompt and text to be summarized. I'll use the same text as in the previous video, the one about the Mojo programming language. Run the cell if you have restarted the kernel. LLM.get numTokens of prompt.format text equals text and the language equals, let's say, English. Okay, there are 251 tokens. I'm creating the chain. Chain equals LLM-chain of LLM equals LLM and the prompt equals prompt. LLM, my object, was defined here in this cell. So run the cell if it's necessary. And the summary equals chain.run and the dictionary as an argument. Text, colon, text. Text on the left side of the colon symbol is the dynamic part of the template, and text on the right side is my variable, this one. And language, colon, Spanish. I'm running the cell. Okay, of course it's prompt, not prom. And here summary. And I'm printing the summary. It's running. And I've got a summary in Spanish. If you want to see the summary in another language, let's say Hindi, you just change the variable. Great. These methods using a basic prompt or a prompt template are good only for a few cases. The text to be summarized and the summary should not exceed the token limit of the model. We'll take a break, and in the next video I'll show you another method of summarizing text. This time we'll do something called stuffing. So far we've seen two simple methods of summarizing text, using a simple prompt and a prompt template. Let's go ahead and see another summarization method called stuffing. Stuffing is the simplest method, and in this method, you simply stuff all the text to be summarized into the prompt as context to pass to the language model. Regarding the length of the document, this is similar to the methods shown previously. This is implemented in LangChain as the stuff document chain. The pros of this method are that it only makes a single call to the LLM, and when generating text, the LLM has access to all of the data at once. The cons are that most LLMs have a context length, and for large documents, this will not work because it will result in a prompt that is larger than the context length. Therefore, the main downside of this method is that it only works with smaller pieces of data. Once you are working with many pieces of data, this approach is no longer feasible. I will show you how to deal with large amounts of text later in the course. I'm importing a prompt template and the chat OpenAI. And I'm importing load summarize chain from LangChain chains summarize, import load summarize chain. I'm also importing the document class from LangChain docstore document, import document. This is a class and it's written with a capital D. This time I'll load the text to be summarized from a text file. This is the famous Steve Jobs speech at Stanford.
Every poster, every label on every drawer was beautifully hand calligraphed.
Good.
Because I had dropped out and didn't have...
I'm opening the file as usual with open files sj.txt as f and the text equals f.read. Let's see the text. If you get this error, Unicode decode error, add a second argument to the open function. Encoding equals UTF-8. This stuff document chain requires a LangChain document format, so I'm generating a LangChain document from the text. Docs equals and the list. Document, this is the class I've just imported, of page content equals text. This is a list with one element, but you can split the text in more than one document if you wish. Use split text or recursive split text. I'm creating the LLM. I'm copy-pasting the line from the previous example. And the prompt template. Write a concise and short summary of the following text. Text colon and the text in curly braces and in backticks. And the prompt equals prompt template of input variables equals text and the template equals prompt template. In fact, I will name the variable template as in my other examples. So template equals template. Next, I'll create the chain. Chain equals load summarize chain. And the arguments are LLM, chain type equals stuff, prompt equals prompt, and the verbose equals false. Use verbose equals true if you want to see details about how the chain runs. And I'm running the chain. So output summary equals chain.run of docs. I'm running the cell. And I'm printing the output summary. And I've got a short and concise summary of the famous Steve Jobs speech at Stanford. We are done with simple methods of summarization. In the next videos, we'll move on to the advanced level. I'll show you how to summarize large documents using different methods, each one with its particularities. I'll see you soon. Let's move on to the next level and see how to summarize large documents that exceed the token limit of the model. In this video, I'll show you how to use a chain called MapReduce. Let me explain to you how it works. This method will split the document into small chunks that fit within the token limit of the model. It will first summarize each chunk, and then it will get a summary of the summaries. MapReduce uses two prompts, an initial one to summarize each chunk of data, and then a different prompt to combine each summary into the final one. The pros of this method are that it scales to larger documents, and the calls to the LLM on individual chunks are independent and can therefore be parallelized. And the cons are that it requires many more calls to the LLM than staff document chain. It also loses some information during the final combining call. If you are on the free plan from OpenAI, you can get into some issues because this method will make multiple API calls to OpenAI, and free accounts are limited to 3 requests per minute. You might need to add a credit card in the billing section. But hey, using GPT 3.5 Turbo is pretty cheap. Summarizing documents that are only a few tens of pages long should keep you under $1 for all the examples in this section. I'm importing the required libraries. And I'm also importing the recursive character text splitter class. I'm gonna split the document in chunks. So from LangChain .text splitter, import recursive character text splitter. Now I'm loading the document. I'm gonna use the same document, the speech of Steve Jobs at Stanford. I'm copy pasting the code from the last video. I'm also creating the LLM. If you want to see how many tokens are in the text, run LLM.getNumTokens of text. I'm creating the text splitter object. Text splitter equals recursive character text splitter of chunk size equals 1000 and the chunk overlap equals 50. This is needed to maintain some continuity. However, pay attention that these numbers are just examples. You should play around with them to see what values fit best for a particular case. And the chunks equals text splitter dot create documents of text. Write text in square brackets because it's a list. Let's see how many chunks are there. There are 17 chunks. There are too many, and it means too many API calls. I'm gonna increase the chunk size to 10,000. Now there are only 2 chunks. I don't want to make so many API calls. And by the way, there are approximately 4 characters in a token. This means that the number of tokens we should expect is 10,000 divided by 4 equals 2,500 tokens in each chunk. Now I'm creating the chain. Load summarize chain of LLM, chain type equals MapReduce, and the verbose equals false. And the output summary equals chain.run of chunks. I'm running it. And I'm printing the output summary. It's still running. It's done. And I've got a good summary. Earlier I said that there are 2 prompts, one prompt for summarizing each chunk and another one for the overall summarization. Let's see the first prompt used for summarizing each part. chain.llm-chain.prompt.template. This is the first prompt. And the prompt for combining the summaries. chain.combine.document-chain.llm-chain.prompt.template. This is the second prompt. These prompts are good, but sometimes you want more. Maybe you want a bullet point summary, or you want it in another language. Anyway, you want to customize the prompts so that they fit your needs best. We'll take a break, and in the next video, I'll show you how to use MapReduce with custom prompts. In the last video, I showed you how to summarize documents that exceed the model token limit using MapReduce. You've learned that the document is split into chunks. Each chunk is summarized with an initial prompt, and the summaries of the chunks are summarized again using a final prompt. These prompts are static. These are the prompts. In this video, we'll dive deeper into this and see how to use MapReduce with custom prompts. The first prompt used to summarize each chunk is called map prompt. Let's define it. Map prompt equals, and a multi-line string. Write a short and concise summary of the following. Text colon and the text in curly braces and backticks. And concise summary. Okay, this is the first prompt. Now I'm defining the prompt template. Map prompt template equals prompt template of input variables equals text as a list, and the template equals map prompt. Now we are defining the second prompt that summarizes the summaries. In this example, we'll generate a bullet point summary. This is especially useful for technical documents. So combine prompt equals. I'm pasting the prompt to save some time. It will be write a concise summary of the following text that covers the key points. Add a title to the summary. Start your summary with an introduction paragraph that gives an overview of the topic, followed by bullet points if possible, and end the summary with a conclusion phrase. And text colon text. This is a better prompt. Now I'm creating the prompt template. Combine prompt template equals prompt template of template equals combine prompt template, and the input variables equals text as a list. I'm running it. And the chain. Summary chain equals load summarize chain of LLM equals LLM, chain type equals MapReduce, map prompt equals, and the first prompt template, map prompt template, and the combine prompt equals combine prompt template. And the verbose equals false. Use verbose equals true if you want to see the intermediate steps. Output equals summary chain dot run of chunks. I have split the document in chunks in the last video. Here. I'm running the code in this cell. It's running, it's making API calls. It's done, and I'm printing the output. And I've got a better summary that has a title, sometimes an introduction paragraph, bullet points with the main ideas, and the conclusion. This is much better since we have a lot of flexibility. That's it for now. In the next video, we'll cover another method of summarization that uses the refine combined document chain. In the last video, we saw how to summarize large documents using the MapReduce chain. In a nutshell, the document is split into chunks that fit within the model token limit. In the first round, each chunk is summarized with an initial prompt. This is the initial prompt. And in the second round, the summaries of the chunks are summarized with a second prompt. This is the default second prompt, and we can use custom prompts if we wish. We'll move on and see another summarization method that uses the refine chain. The document is split into chunks as well. This method starts by generating a summary for the first chunk of data. The summary of the first chunk is passed in along with the second chunk, and the LLM is asked to refine the summary based on the new document. At this moment, we have the summary of the first chunk and second chunk. For the next round, the LLM will summarize the document composed by the actual summary and the third chunk, and it continues until it's done with all the chunks. This method has several advantages. First, it can pull in more relevant context from the previous documents. Second, it may be less lossy than the MapReduce document chain method. However, this method also has several disadvantages. First, it requires many more calls to the LLM than the stuff documents chain or MapReduce methods. Second, the calls are not independent, which means that they cannot be parallelized like in the case of the MapReduce chain. In this notebook, we have written a lot of code in different cells, and it can be chaotic. I'll add the complete code for this example to run, starting with this cell. I'm importing all required libraries and loading the API keys in environment variables. In this example, I'll summarize a PDF file. It's the famous attention is all you need document, which is the foundation of the transformer technology used by all these LLMs. I'm reading the file using unstructured PDF loader. You can also load the file using PyPDF. So loader equals unstructured PDF loader and the path to the file. Files, attention is all you need.pdf. It reads the entire document in a list with a single element. It doesn't read the document page by page. I'm loading the data. Data equals loader.load. Data is a list with a single element that contains the entire content of the PDF. And don't forget to install this package to use the unstructured PDF loader. So run pip install unstructured. The package was installed, and I'm running the code that loads the PDF file again. Okay, I have to install PDF to image too. It's done, and I'm running the code again. The PDF was loaded in data, which is a list with a single element that contains the entire content of the PDF. If you want to see the content of the file, run print data of 0 dot page content. This is the content of the PDF. I'm creating the text splitter and split the document in chunks of 10,000 characters. This is approximately 2,500 tokens. Text splitter equals recursive character text splitter of chunk size equals 10,000 and chunk overlap equals 100. And chunks equals text splitter dot split documents of data. This returns a list of documents. Let's see how many chunks do I have. There are 4 chunks. Okay. Now I'm creating the LLM. In fact, I'm copy pasting the line of code from a previous example. It's a good idea to check the cost, so I'm pasting the code that calculates the cost. Summarizing the document will cost 1.8 cents. It's pretty cheap. Now, I'm defining the chain by calling load summary chain. Chain equals load summary chain of LLM equals LLM. Chain type equals refine. And the verbose equals false. We have written this code in the example from the last video too. And I'm running the chain. Output summary equals chain.run of chunks. I'm running it. Note that it will take some time. It can take a minute or two because it will make more LLM calls. I'm pausing the video until it's done. It's done and I'm printing the summary. I've got a good summary of the PDF file. If you want to see how it summarizes step by step, use verbose equals true. We'll take a break, and in the next video, we'll see how to summarize using the refined chain and custom prompts. In the last video, I showed you how to summarize documents that exceed the model token limit using the refined chain. The document is split into chunks, and a summary of the first chunk is generated. It is passed in along with the second chunk, and the LLM is asked to refine the summary based on the new document. So basically it means adding a new chunk to the existing summary and generating a new refined summary. In this video, we'll dive deeper into this and see how to use the refined chain with custom prompts. I'm defining the initial prompt template used to produce the summary of the first chunk of data. I'm pasting the code. Write a concise summary of the following, extracting the key information. Text and concise summary. And the initial prompt equals prompt template of template equals prompt template, and the input variables equals text. Of course, this is a list. Next, I'll define the refine prompt template that will be used for the rest of the document. It will refine the existing summary with the next chunk of data. This is the refine template. It will produce a bullet point summary with an introduction paragraph and a conclusion phrase. And the refine prompt equals prompt template of template equals refine template, and the input variables equals a list with two elements, existing answer and text. There are two variables in the refine template, two dynamic parts. So existing answer and text. I'll write it on multiple lines so that you can see it better. Now the chain. Chain equals load summarize chain of LLM equals LLM, chain type equals refine, question prompt equals initial prompt, refine prompt equals refine prompt, and return intermediate steps equals false. Use true if you want to see the intermediate steps. And that's it. I'm running the chain. Output summary equals chain.run of chunks. Note that it takes some time based on how many chunks you have. I'll print the output summary. We are waiting until it's done. Okay, it's done. Let's see the summary. And I've got a much better summary. The summary has an introduction, bullet points with the main ideas, and the conclusion. We are done with the refined chain. You now know how to summarize documents using this advanced method. You can also customize your prompts for the best results. We'll move on and see the last method of summarization that uses LangChain agents. Welcome back. This approach will use LangChain agents. This is still a very actively developed area and should be handled with care. Future agents will be able to handle a lot more complicated tasks. I'm importing chat OpenAI. And from LangChain.agents, import initialize agent and tool, the tool class. And from LangChain utilities, import Wikipedia API wrapper. I'm also loading the environment variables. I want to have all the code starting from this point. I'm creating the LLM. I'll use GPT 3.5 Turbo. And I'm also creating an object called Wikipedia. Equals Wikipedia API wrapper. I'm sure you realized that we'll summarize some Wikipedia pages. I'm creating the tools for the agent. When constructing your own agent, you will need to provide it with a list of tools that it can use. Tools are ways that an agent can use to interact with the outside world. I'm creating the toolkit for this agent. This is a list of instances of the tool class. And this agent will have a single tool. A tool has at least a name and a function. So name equals Wikipedia. Name is required and must be unique within a set of tools provided to an agent. And func equals wikipedia.run. The tool will call the run method of the Wikipedia object. Description is optional but recommended, as it is used by an agent to determine tool use. So description equals and a description. For example, useful for when you need to get information from Wikipedia about a topic. The next step is to initialize the agent. Agent executor equals initialize agent of tools LLM agent equals zero shot React description and verbose equals true. I want to see what it does step by step. Finally, I'll run the agent with the question as an argument. So output equals agent executor.run and the question. Can you please provide a short summary of George Washington? And I'm printing the output. I'm running all the cells again. And you see the agent in action. You see the chain of thoughts. You see a plan, an action input, an observation, a summary, and so on. It's done. I'm running the code that brings the output. And I've got a summary of George Washington from Wikipedia. We've reached the end of the project. This application we have built can be used to summarize documents quickly and easily. This makes it a valuable tool for anyone who needs to summarize large amounts of text, such as students, researchers, or business professionals. We used LangChain, which makes it easy to create state-of-the-art LLM applications. You learned how to create a summarizer by leveraging the power of LangChain components such as chains, agents, and OpenAI. Good luck summarizing. We live in an era where data science, machine learning, and artificial intelligence are reshaping our world. Large language models and generative AI applications have the potential to revolutionize the way we work, making us more productive and efficient. Jupyter Notebook is a great tool for writing code, prototyping, and experimentation, but it is not designed for production or for end-user use. If you want to deploy your application to production so that it can be used by anyone, not only by developers, you will need to build a web app or a front-end for it. Streamlit is an open-source Python library that makes it easy to create and share custom web apps and front-ends for machine learning and data science. With just a few lines of code, you can build and deploy powerful data apps in minutes. There are many other libraries that can be used to create frontends, so why should you choose Streamlit? When choosing a new tool to learn, you invest time and effort, so if you are probably wondering if it's a popular tool, if many other users use it, and if the technology is in decline or not. Take a look at this chart that shows GitHub start history. You can see how different libraries used for visualization have evolved over time. Streamlit has had an explosive breakout in the last few years. It's well maintained and also has a huge popularity. You can't go wrong with Streamlit. It's easy to learn and use and can help you create web apps, much faster than traditional web development frameworks. It is also geared towards data science and machine learning applications. Let's move on and install Streamlit. We'll write the code in PyCharm, but any other IDE like Visual Studio Code is also a good option. We won't use Jupyter Notebook because creating a web app inside another web app can be problematic. If you developed your application in Jupyter Notebook, as we will need to do in many sections, just export it to a .py file. Go to File, Download As, and select python.py. This is the exported .py file. Or, if you just have a single file with some functions and a few lines of code, copy-paste it into PyCharm. I recommend setting up a virtual environment to ensure that the dependencies needed for Streamlit don't impact any other Python projects we are working on. To install Streamlit, activate the virtual environment and run the following command in the terminal. pip install Streamlit. You can also run the command in cmd.exe or PowerShell. And to upgrade it, run pip install Streamlit --upgrade. Or, if you prefer, in PyCharm, go to Settings, search for Interpreter, select the Python interpreter, click plus, search for Streamlit, and install it. Once Streamlit is installed, test the installation by running the following command in the terminal. Streamlit hello. This should open up a new tab in the default browser with an example of a Streamlit app. That's all about the introduction to Streamlit and the installation. We'll take a break, and in the next lecture, we'll go over Streamlit's main components. In this video, we'll go over Streamlit's main components. You'll learn how Streamlit works and how to run a Streamlit application. Working with Streamlit is simple. In a Python file, you import the Streamlit library, add a few components like charts, widgets, or tables, and the logic of the application. This source file is just an example of a Streamlit app, and I don't want you to focus on the details. Ignore the widgets and all the other components for now. We'll have plenty of time to dive into all of them later on. Just have a high-level overview. To run the application, in the terminal, run Streamlit, run, and the name of the Python file. Pay attention to use a correct relative or absolute path to the file. In this example, Streamlit_demo.py is in the Streamlit_project directory. So I'm moving to that directory and I'm running Streamlit, run, and the name of the file. Streamlit_demo.py. As soon as you run the script, a local Streamlit server will spin up and your app will open up in a new tab in the default browser. I'm hitting enter. To stop the Streamlit server, press Ctrl+C in the terminal or click X. This one. This app is your canvas where you'll add text, charts, widgets, tables, and more. Every time you want to update the app, save the source. When you do that, Streamlit detects the change and asks you whether you want to rerun your app. I'm changing the code and saving the file. Take a look here. It says source file changed. You can choose always rerun at the top right of the window to automatically update your app every time you change its source code. This allows you to work in a fast, interactive loop. You type some code, save it, try it out live, then type some more code, save it, try it out, and so on until you get the expected results. Some developers prefer to lay out the editor and browser windows side by side, so the code and the app can be seen at the same time. Like this. You can give it a try to see if you like it. Anytime something must be updated on the screen, Streamlit reruns your entire Python script from top to bottom. This can happen in two situations. Whenever you modify your app's source code, like this, you can see the change. The app was updated. And whenever a user interacts with the widgets in the app. For example, when selecting a checkbox, entering text in an input box, or clicking a button. Like this. I'm dragging the slider to the right to change the temperature, which is shown in degrees Celsius. Streamlit detected that the user interacted with this widget and has rerun the entire Python script and updated the text below that shows the temperature in Fahrenheit. Because Streamlit runs the script from top to bottom at every user interaction or code change, it makes the development super easy, but it also comes with some overhead which slows down the application. To avoid rerunning time-consuming code after every single action when nothing has really changed, Streamlit comes with a built-in caching mechanism that speeds things up. Caching stores the results of the function calls so they only need to run once, and it also keeps some persistent objects across reruns. This makes your app much faster. By the way, if you want to change the theme to the dark one, go to Settings and choose the dark theme. Many people prefer dark themes. In this lecture, you learned about Streamlit's main components. You now know how Streamlit updates the frontend at each source update or user interaction. We'll take a break, and in the next videos, we'll go over different Streamlit components. We'll talk about displaying style and data on the screen, widgets, drawing charts, layout, showing progress, session state, callbacks, and more. In this video, I'll show you how to display data on the screen. I'm importing Streamlit as ST and Pandas as PD. If you don't have Pandas installed, just install it by running pip install pandas. There are two ways to display data on the screen, using STWrite or using Magic. STWrite is Streamlit's Swiss Army knife. You pass anything to STWrite and Streamlit will display it on the screen. Let's write a simple text to the screen. st.write and the text. We learn Streamlit. And I'm running the app. In the terminal, I am moving to the projects directory, Streamlit project. And I'm running Streamlit, run, and the name of the file, stwrite. Okay, this is our app. We see the text, we learn Streamlit. Using STWrite, we can also display a list, a dictionary, or anything else. For example, L1 equals 1, 2, 3. This is a list. And the STWrite of L1. I'm clicking Always Rerun. It has rerun the script from top to bottom and displayed the list. Let's display a dictionary. L2 equals list of and the string ABC. And I'm creating a dictionary D1 by calling dict of zip of L1 and L2. And the st.write of D1. And you see the dictionary. Let's talk about the second method called magic. Anytime Streamlit sees a variable or a literal value on its own line, it automatically writes that to the screen using STWrite. For example, this is a string literal displaying using magic and smile. And you see the string. Note that you can also write emoji using shortcodes. Shortcodes are a way to enter emojis using pure ASCII. You can type this : smile : to show a smiling face. These are all the emoji shortcodes supported by Streamlit. Notice that you can also enter emojis directly as Unicode in your Python scripts too. It's not necessary to use a shortcode. Let's display a pandas data frame, which is in fact a table using magic. I'm creating the data frame, df equals pd.dataframe, parentheses, and a dictionary. First column, and the list 1, 2, 3, and 4. And the second column, colon, and another list 10, 20, 30, and 40. This is the data frame, and I'm writing df on its own line. Let's see the app. Take a look here. This is the pandas data frame. This is magic and is equivalent to st.write of df. Besides stwrite, there are also other data-specific functions like stDataFrame and stTable for static table generations and so on. Let's set the page title using st.title. I am adding it at the beginning of the file. st.title and the string hello Streamlit world. And I'm also adding an emoji using a shortcode. Let's see the app. And the title was displayed at the top of the file. Good. The easiest way to learn how to display and use Streamlit components is to try them out yourself. Okay, in this video, I showed you how to display data on the screen using st.write or magic. In the next video, I'll teach you how to use Streamlit widgets. In this video, we'll go over Streamlit widgets. I'm creating a new file. st_widgets. And I'm importing both Streamlit and pandas. With widgets, Streamlit allows you to add interactivity to your apps with the help of buttons, sliders, select boxes, text inputs, and more. Let's take a look at the most commonly used widgets. I'm starting with probably the most common widget, which is text input. You create a text input using st.textInput and it will display a single line text input widget. So st.textInput. The only required argument is a short label explaining to the user what is this input used for. For example, your name. The method will return the string entered by the user, so name equals. When the user enters a string and hits enter, the method will return the string entered by the user. So if name, colon, this means the user has entered something and hit enter, st.write, and I'm displaying hello and your name using an f string. So hello, name. Note that you should always treat your widgets as variables. I'm running it. Streamlit run st widgets. This is the text input and I am entering Andre and hitting enter. And it displayed below hello Andre. Now I'm creating a numeric input widget that accepts only numbers. For example, x equals st.number input. The first argument is the label, enter a number. The second argument, min value, equals 1. Max value equals 99. And the step equals 1. The user will be able to enter numbers from 1 to 99 in steps of 1. And you can access the value at any point using the variable x. For example, st_write, the current number is, and x in curly braces. This is an f string. I'm clicking always rerun. Good. I'm adding a horizontal line for a better readability. st.divider. This will add a horizontal line. This is the line. This was number input. Let's talk about the button. I'm creating a button with st.button. So st.button, and it requires a single argument, which is the label. For example, click me. When the user clicks the button, the method will return true. So clicked equals true. And we can use an if statement to do something when the user clicks the button. For example, if clicked, if the user has clicked the button, st.write, and I'm displaying something. I'm gonna display a ghost emoji. Times 3. This is the button, and I'm clicking it. Very nice. I'm adding a new horizontal line to separate the widgets we are talking about. So st_divider will draw a horizontal line. Let's talk about the checkbox. Let's display a checkbox widget, which is also very common. For example, agree equals st.checkbox of, and the only mandatory argument is the name of the checkbox. For example, I agree. When the user checks the widget, the method returns true. So if agree, this means that the user has checked the box. I'm printing a message, this time using magic. For example, great, you agreed. This is the checkbox, and I'm checking it. If you want to have the checkbox selected when the app first runs, add a second argument, value equals true. Like this, checked equals st.checkbox of continue, and the value equals true. And if checked, I'm gonna display another emoji. This one, times 5. And you can see that the checkbox is already selected. One use case for checkboxes is to hide or show a specific chart or section in an app. I'm creating a pandas data frame. df equals pd.dataframe of, and the dictionary. Name, colon, and the list with some names. For example, N, Mario, and Douglas. And the age, colon, and the list with some numbers. 30, 25, and 40. This is the pandas data frame. And the checkbox. If st.checkbox of show data, if the user is checking the box, I'm displaying the data frame. st.write of df. I'm checking show data. And we see the data frame. Let's go ahead and display a radio button. I'm creating the options list. For example, pets equals cat, dog, fish, and turtle. To create the radio button, use st.radio. So pet equals st.radio, and it has two required arguments. The label explaining to the user what this radio group is for, and the options list. So, favorite pet and pecs. When the user selects an option, the method will return the value of that option. So st.write and an f string, your favorite pet, colon, and pet in curly braces. You see the group, and I'm selecting dog, fish, turtle, cat, and so on. And the corresponding message is displayed below. You can also add a third argument called index to pre-select a specific option at the first run. For example, I want the fish to be selected when I first run the application, and I'm adding index equals 2, 0, 1, and 2. Fish is at index 2. Now, fish is selected. Widgets can also be accessed by key if you choose to specify a string to use as a unique key for the widget, like this. This has to do with the Streamlit session state, and we'll talk about it later in the course. I can access the value like this too. st.sessionState.yourPet. The value of the key. Good. Let's go ahead and talk about the select widget. Let's see how to create a select box. I'm defining a list. Cities equals London, Berlin, Paris, and Madrid. And city equals st.selectBox. The first argument is the label, your city, and the second argument, the list, cities. And I'm displaying the city selected by the user. So st.write, you live in city. You can see the select box. I'm selecting Berlin, and it displayed you live in Berlin, or Madrid, you live in Madrid. You can also add an index to set the pre-selected option on the first render. Like this. I want Berlin to be selected. So index equals 1. Now Berlin is selected, not London. I forgot to add the horizontal line between the widgets. I'm adding it. So st.divider here and st.divider before the radio buttons. We are now taking a break, and in the next video we'll talk about some other widgets: slider, file uploader, and camera input. I'll see you soon. The next widget we'll take a look at is the slider. This supports int, float, date, time, and datetime types. The default slider type is int. To create a slider, use st.slider. X equals st.slider. The required argument is the label or the name of the slider. For example, X. And I'm displaying the value of X. st.write, X is, and X in curly braces. On the first run, the app will output the text X is 0. This is the slider, and you can see that X is 0. If you want to set the slider to a specific value on the first run, add an argument called value. Value equals 15. Now, when the app first runs, it sets the slider to 15. As you can see, by default, an int slider goes from 0 to 100. You can set the range using min value, max value, and step to customize your slider. For example, min value equals 12, max value equals 78, and the step equals 3. This will adjust the minimum and the maximum value for the range and the interval you can select. It goes from 12 to 78 in steps of 3. Let's go ahead and see a file uploader widget. Let's add such a widget. Uploaded file equals st.fileUploader. And the required argument is the label. Upload a file. By default, uploaded files are limited to 200 megabytes. You can configure this using server.maxUploadSize config option. This is the file uploader widget. And you can click Browse Files to select a file to upload. If you want to allow only some extensions, add a second argument called type. This is a list of allowed extensions. For example, I'm allowing only TXT, CSV, and the Excel files. Only TXT, CSV, and Excel files are allowed. The PDF file that exists in this directory is not shown anymore. Now, let's read and display the content of the file. So if uploaded file equals true, st.write uploaded file. I'm displaying the object. And I'll add an if statement to read the file based on its type. I'm selecting a CSV file, and we can see the object, the uploaded file object. There's a parameter called type that holds the type of the file. In this case, is a text CSV. If I select a TXT file, the type will be text plain. I'm adding the if statement. If uploaded file dot type equals text slash plain, if it's a TXT file, I'm reading it as a TXT file. From IO, import string IO, and I'm converting it to a string-based IO using the UTF-8 encoding scheme. So string IO equals the string IO class of uploaded file dot get value dot decode of UTF-8. And I'm reading the file as a string. So string data equals string IO dot read. I'm displaying it in the app. st.write of string data. But if it's a CSV, I'll read it using pandas. So if uploaded file dot type equals text slash CSV, I'm importing pandas as PD, and the df equals pd.read underscore CSV of uploaded file. And the st.write of df. Here it's elif. And finally, the last option, if it's an Excel file, else df equals pd.readExcel of uploaded file, and the st.write of df. Let's test it. I'm selecting the CSV, and we see the contents of the file. Now I'm selecting the txt file, and it read and displayed the txt file. And finally, I'm selecting the Excel file, and we can see the content of the Excel file. Very well. Let's move on and talk about the camera input. Let's see how to capture and display the image of the user's webcam. st.cameraInput displays a widget that returns pictures from the user's webcam. I'm taking a photo using the camera on my laptop. So camera photo equals st.cameraInput. And the label. Take a photo. And I'm displaying the image. If camera photo st.image of camera photo. Let's see the image captured by my webcam. And that's me. By the way, you can display an image in the app using st.image and passing the path to a local image file or a URL to a remote image. st.image of, and I'm pasting a URL to a remote file. The file is from the streamlit.io website. This is the file. We are done. I've shown you the most common and used widgets. We are taking a break, and in the next video, we'll talk about the layout. Let's talk about the layout of the application. Streamlit makes it easy to organize your widgets in a left panel sidebar with st.sidebar. Each element that's passed to st.sidebar is pinned to the left, allowing users to focus on the content of their app while still having access to those controls. I'm adding a select box to the sidebar. Import Streamlit as st, and my select box equals st.sidebar.selectBox. And the label, and the second argument is a list with the options: US, UK, DE, and the FR, some country codes. I'm running the app. Streamlit run and the name of the file, st_layout.py. This is the sidebar with the select box. You can add more elements to the sidebar. I'm adding a slider. My slider equals st.sidebar.slider. And the label will be temperature. This is the slider on the sidebar. Okay, that's it. In the next video, we'll talk about another way to control the layout of your application, and we'll talk about columns. Beyond the sidebar, Streamlit offers several other ways to control the layout of your app. st columns lets you place widgets side by side. st columns takes an argument that controls the number and the width of the columns to insert. This argument can be an integer that specifies the number of columns and all columns have an equal width in this case, or an iterable of numbers, int or float, that specifies the relative width of each column. Let's create two equal columns. This will return two columns. Left column and the right column. st columns returns a list of container objects. You can use the with notation to insert any element into a column, or you can call methods directly on the return objects. I'm generating a random list and drawing a line chart in the left column. Import random and the random list. Data equals list comprehension random.random for underscore in range of 100. I'm generating a list with 100 random elements. And I'm using with to add some elements to the left column, a subheader and the line chart. So with left column, colon, st subheader, and the string, a line chart. And the line chart, st.linechart of data. Let's take a look at the left column. This is the left column, which contains a line chart. Now, I'm calling some methods directly on the column object to add elements. Right column dot subheader of data. And the right column dot right, and I'm adding the first 10 elements of the list. So data and the slicing, colon 10. This will return the first 10 elements of the list. This is the right column. Let's create 3 columns with a different width. Call 1, call 2, and call 3 equals st.columns of and the list 0.2, 0.5, and 0.3. This creates 3 columns where the first one takes up to 20% of the available width, the second one takes up to 50%, and the last one takes up to 30%. I'm adding a markdown to column 1, so call 1.markdown of hello Streamlit world. I'm adding some values of the list to the second column. I'm adding 5 elements. And I'm adding an image to the last column. So with call 3, I'm using with st.header a cat, and the st.image and the URL to a cat. Let's take a look at the application. These are the columns. The first column, the second one, and the last, the third column. Let's go ahead and talk about another layout element called expander. An expander is a multi-element container that can be expanded or collapsed. It inserts a container into your app that can be used to hold multiple elements. It can be expanded or collapsed by the user. When collapsed, all that is visible is the provided label. To add elements to the returned container, you can use with. This is the preferred notation, but you can also call the methods directly on the return object, on the expander. So with st.expander of and the label, click to expand. And I'm adding a bar chart, st.barchart, and the argument will be a dictionary. Data, the key, and the value will be a list with random values. So random.randint of 2 and 10. This will return random numbers for 2 to 10. 4 underline in range of 25. I'm generating 25 random numbers. And I'm also adding an image, st.write. This is an image of a dog. And the st.image and the URL to the image. Let's test it. This is the expander, and I can click to expand it. This is the bar chart, the text, and the image. Note that currently you cannot add an expander into another expander. In this video, I'll show you how to display a progress bar if you have an extensive computation. This is useful because it indicates whether the code is running or is stuck in a loop due to errors. st.write starting an extensive computation. I'm adding a placeholder using st.empty. This is a container in your app that can be used to hold a single element. I will update this container with the iteration number. And the st.empty will return the latest iteration. I'm defining the progress bar text. So progress text equals operation in progress. Please wait. And my underscore bar equals st.progress of 0 and the text equals progress text. This is a message to display above the progress bar. And the time.sleep of 2 to simulate an extensive computation. And a for loop. This will update the progress bar with each iteration. So for I in range of 100, my bar dot progress of I plus 1. And I'm updating the text of the empty container with the iteration number. I'm updating latest iteration. Latest iteration dot text of and an f string. Iteration and in curly braces I plus 1. Of course, this is inside the for loop. I'm introducing some artificial time to simulate an extensive calculation. Time.sleep of 0.1. And at the end, outside the for loop, I'm writing a message. st.write, we are done. And an emoji. I'm running the application. Streamlit run and the name of the file. You see the text, the iteration, and the progress bar. It goes from 1 to 100. And we are done. Very well. In this video, you learned how to create a progress bar. This is useful to indicate the user that the code is running and it was not stuck. And it is not stuck. When you create a Streamlit app and open it in your browser, this is what we refer to as a session. A session is a Python object that exists in memory for you to use it between runs. A session state is a way of sharing variables between runs. In addition to the ability to store and persist state, Streamlit also exposes the ability to manipulate the state using callbacks. We'll talk about callbacks in the next video. The session object exists as long as the user keeps a browser tab open and the connection between the frontend and the backend, which is the server, is active. Each time you open a new tab in your browser and go to your Streamlit app, a new session is created. These sessions are independent. A session is what happens in the browser, and the state is how we capture that and store the current value of widgets and parameters to use later in the same session. Let's see how to use the session state. I'm setting the page title. Streamlit session. You can access the session state using st.sessionState. Let's display the session state object. st.write of st.sessionState. And I'm running the application. Streamlit run st_session_state, the name of the Python file. At this moment, the session state is empty. Think of the session state as a dictionary. You can add a key value pair to the state to remember the history of different widgets, values, and parameters when your app reruns. Let's add a new key value pair to the state. I'll add a counter to save the number of times the page was reloaded. There are two notations when adding a new element to the state, using brackets and using ducks. Before adding a new value to the session, check that it doesn't already exist. So if counter not in st.sessionState, I'm creating it. This is the first time we load the page. So st.sessionState of counter, this is the brackets notation, equals 0. And else, the page was already loaded, so the session state already exists, and this is a reloading. I'll use the dot notation. st.sessionState.counter plus equals 1. I'm incrementing it by 1. You can access a value of a key in the state as a value of a key found in a dictionary by using the brackets notation or as an attribute of an object using the dot notation. I'm displaying the value of the counter. st.write counter, colon, and in curly braces, because this is an F string, st.sessionState.counter. Let's take a look at the app. I'm reloading the page by hitting R or by clicking rerun. Okay, I mistyped it. X counter. We notice how the counter is incremented with each page rerun. I'm reloading the page by hitting R. The value of the counter is persistent between different runs. Now I'm creating a widget button. Button equals st.button of update state. And I want to store in the state how many times the user clicks the button. First, I'm creating a new value in the state. If clicks not in st.sessionState, st.sessionState of clicks equals 0. I'm initializing it with 0 because on the first run the button was not clicked. And if button, this means that the button was clicked. Remember that st.button returns true when it is clicked. I'm incrementing clicks by 1. So st.sessionState of clicks plus equals 1. And I'm displaying the session state after pressing the button. I'm using magic. I'm just writing the string literal after pressing button. And in curly braces, st.sessionState. I am clicking update state. Clicks 1 and counter 29. Clicks 2, clicks 3, and so on. The state is updated each time the user clicks the button. Let's go ahead and see how to connect a widget value to the session state. I am creating a slider widget. Number equals st.slider, value, the label, 1 and 10. 1 and 10 are the range. The range of values will be between 1 and 10. To store the value of this widget in the session state, I'll use an argument called key. So key equals my slider. And the value of the key will be saved in the session state. Let's display the session state. st.write of st.sessionState. This is the slider and this is the session state. And we notice a key called mySlider in the session state with the value of the widget. x6, now x4, and so on. We can also have access to the value of the slider in the number variable. In this one, st.write of number. Take a look here. This is the number 3, 5, and so on. Alright, that's all about the Streamlit session state. In this video, you learned what the session state is, how to add values to it, and how to access it. You've also learned that the session state is a way to share variables between application runs. In this video, we'll talk about callbacks. A callback is a function that gets called when the user interacts with a widget. We use callbacks via the onChange or onClick parameters of the widget. The onChange or onClick parameters accept a function name as an input argument. This function is the callback. Normally, when you interact with a widget, like pressing a button or selecting a radio button, the entire Python script is rerun from top to bottom. However, if you use the onChange or onClick parameters, when Streamlit detects a change in the widget state, it will run the function specified in the onChange or onClick parameters and then will rerun the script as usual. So this is an extra task for Streamlit before rerunning the script. OnChange works for input widgets like slider or input text, and onClick works for one-off widgets like buttons. Let's see the code. I'm creating an app that converts miles to kilometers and kilometers to miles. st.subheader distance converter. I'm defining a column for miles, a column for kilometers, and a buffer between them. So call1, buff, call2 equals st.columns of, and the list 2, 1, and 2. The miles and the kilometers columns are 2 times larger than the buffer. In the left column, I will display a number input widget for the distance in miles. So with call1, miles equals st.number input of miles, the label. I'm also adding key equals miles to update the session state with the value of this widget. And in the right column, I will display a number input widget for the distance in kilometers. With call2, km equals st.number input of kilometers, km and colon. And the key equals km. This is for the state. When the user enters a value in miles or kilometers in one number input, I want to update the other one with the corresponding value. I'm adding the onChange parameter to each widget, and x value will be the name of a function that makes the conversion. In the miles number input, I am adding onChange equals miles to kilometers, km. And in the kilometers input number, I'll add onChange equals kilometers to miles. Now I'm defining the function miles to kilometers and kilometers to miles. df miles to kilometers. I am accessing the value of the widget using the session state. So st session state.km equals st.session state.miles times 1.7 609. This is the formula that converts miles to kilometers. And I'm defining the second function as well. Kilometers to miles. And this time I'll have st.sessionState.miles equals st.sessionState.kilometers times 0.621. And that's it. I'm running the application. This is the app. I'm updating the value in kilometers here, and the application automatically updates the value in miles. Or I can update the value in miles, and the application will update the value in kilometers. What happens behind the scenes is that when Streamlit detects the change in the kilometers or miles number input, runs the function specified in the onChange parameter, and then reruns the entire script from top to bottom. The function converts kilometers to miles or miles to kilometers and updates the value of the other widget. Alright, we are done with this section about Streamlit. You've learned a lot. You now know how Streamlit works, how to add widgets, how to create the layout of the application using a sidebar, an expander, or columns. You've learned about session state and callbacks, and you have the skills to create beautiful front ends for your data science or generative AI applications. Let's go ahead and talk about while and continue. Earlier, we saw that we can use the break and continue statements with for loops. These statements, break and continue, can also be used with while loops, having almost the same effect. Let's start with the continue statement. The continue statement continues with the next iteration of the loop, or in other words, it returns the control back to the beginning of the while loop. Let's create a new script. This script will print out all numbers divisible by 13 that are less than 100. So x equals 12, I'm starting from 12, and while x less than 100, this is the test condition, x equals x plus 1, and if x mod 13 not equals 0, continue. Because there's a single instruction in the code block, you can write it on the same line with the if statement or on its own line. And print x. Print x belongs to the while loop. It doesn't belong to if. What does this mean? If the remainder of x divided by 13 is not 0, it means that the number is not divisible by 13 and the continue statement gets executed. The continue statement stops the current iteration and continues with the next iteration of the loop. So what comes after continue will not be executed. But when x is divisible by 13, the if test condition is false, continue doesn't get executed, and the instruction that follows is executed. So the print function. This is the logic behind this piece of code. I'm running it. It printed out all numbers divisible by 13 less than 100. Now, I want to show you a common mistake. If I increment x at the end of the code block, it won't work. Like this. Pause the video and think about what will happen. I'm running the script. It seems that nothing is happening, but the program entered into an infinite loop. I have to stop it manually. Can you tell why has that happened? So, x is 12, it enters the while loop and tests if x is divisible by 13. The test condition is true because 12 mod 13 is 12 and is different from 0, and the continue statement gets executed. This means it will return to the while statement and test again if 12, x is still 12, is less than 100. Of course, it is. It enters the while loop and executes the same code again and again. It will never reach the line that increments x by 1. We are at the end. That's all about while and continue. In the next video, we'll go over while and break. The break statement breaks out of the innermost enclosing for or while loop. It terminates the current loop and resumes the execution at the next statement after the for or the while loop. If the break statement is inside the nested loop, so a loop inside another loop, break will terminate only the innermost loop. A single line of code makes more sense than some words, so let's see some practical examples. In the first example, the program will prompt the user for a number continuously until he enters the lucky number. While true. I'm entering into an infinite loop. I want to interrupt the loop only when the user enters a specific number by executing the break statement. So, guess equals int of input of enter your lucky number between 1 and 10. By the way, I'm converting a string to int. The lucky number will be 7. It's hard-coded, but you can choose it randomly or any other way. So if guess equals 7, print you won. And of course, break. I'm breaking the loop because the user entered the lucky number. If he doesn't enter the lucky number, break is not executed and the program returns to while and executes the next iteration of the loop. If the condition is false, I'm displaying guess in curly braces, x an f string, was not a lucky number. I'm running it. And I'm entering 9. 9 was not your lucky number. 7. And I won. Let's see the second example. I've already done it to save time, but no worries, I'll explain it to you in detail. This piece of code finds and displays all prime numbers less than a number entered by the user. A prime number is an integer greater than 1 whose only factors are 1 and itself. It has no other divisors. For example, 5, 7, and 11 are prime numbers. So, while a greater than 1, a is going backwards to 2 included. I'll test all numbers from a to 2 if they are primes. b equals a, the floor division operator, 2. So b equals a divided by 2. I'll search the divisors from 2 to half a. In fact, I'll also search backwards from half a to 2. It's not necessary to search for any divisors greater than half a because when I divide a by that number, the result will always be 1 point something. By the way, I used the floor division operator because I only need the quotient of a divided by 2. And this is the inner loop. If a mod b equals 0, means that I'm testing if b divides a. If yes, that means that b is a divisor of a and a is not prime. In this case, I'll break out the inner loop. The next instruction of the outer loop will be a minus equals 1. I'm decrementing a by 1 and I'm entering the main loop again. I'm running the script and I'm entering 499. In this example, a is 499, which is greater than 1. If at a specific iteration there's no b that divides a, it means that the break statement of the inner loop will not be executed for that a. And the conclusion is that a is a prime number. The else clause of the inner loop is executed, printing that a is prime. By the way, this else clause belongs to the inner while. I'm hitting enter. And it displayed all prime numbers less than or equal to 499. This was quite a difficult example showing you how to use while loops with break and else statements to solve a common problem. Take your time to fully understand this piece of code. In the next video, we'll go over the walrus operator, and with it, the entire section on Python loops will be completed. I'll see you in a second. Let's go ahead and talk about list slicing. Lists can be sliced like strings. I am creating a new list. Numbers equals 1, 2, 3, 4, 5. And nums equals numbers of 1, 4. Remember that the start is included and the stop is excluded. So I'm slicing the list numbers from index 1 included to index 4 excluded. By the way, slicing returns a new list. The initial one is not modified. Let's see some other examples. Print numbers of colon 3. By default, the start index is 0. And I've got the elements from index 0 to index 3 excluded. Elements from index 0, index 1, and index 2. And if I do print numbers of 2 colon, I'll get all the elements from index 2 included to the end of the list. By default, the stop index is the end of the list. You can also use a step as the third index. Let's see an example. Numbers of 1, colon 5, colon 3. In this example, the step is 3. And by default, the step is 1. Note that negative steps are allowed. Numbers of 4, colon 1, colon minus 2. I'm going backwards. From index 4 included to index 1 excluded in steps of 2. And print of numbers of colon colon will return the entire list. In fact, this is a copy of the list. And if I want to reverse the list, I can do numbers of colon colon minus 1. I am reversing the list. Also note that out-of-bound slicing doesn't return error. For example, numbers of 1 colon 100. There will be no errors. Note that slicing modifies a list. For example, numbers of 0 colon 2 equals and a new list, A and B. I'll replace the items returned by slicing with A and B. And I can also do something like this. Numbers of 0 colon 2 equals and a list with 3 elements, X, Y, and Z. And I'm printing the list. There will be no errors because using slicing you can also insert new items in the list. Let's talk about the last operation, which is the iteration. For readability, I'll add a few hashes. You have to take a look below this point. Let's see how to iterate over a list. I have a list of IP addresses and I want to iterate over the list. Let's suppose this is a Python script for network automation and I want to connect to each server using SSH and run some specific commands to make a backup or install some packages. So, for a temporary variable, let's say IP in and the name of the list, IP underline list, colon, and the code block of the for loop, print connecting to IP. This was the iteration. Finally, if you want to check the membership of an item to the list, use the in or not in operators. For example, print 10.0.0.1 in IP list. And of course, it will return true because this string is an element of the list. But 192.100 in IP list will return false. This element does not belong to the list. Let's try another one. Print 192 not in IP list. What do you think? What will it return? And of course, it will return true. The string 192 is not an element of the list, so not in will return true. We are done with the most common list operations. In this video, you've learned how to concatenate 2 or more lists, how to slice lists, how to iterate over one, and how to test a list membership. Hey guys, and welcome back. This will be very interesting. Let's talk about list comprehension, one of the most powerful features of Python. It's the Pythonic way of constructing a list. What is it all about? List comprehension offers us a shorter and more concise syntax to create a new list based on the values of an existing iterable. Let's see how we can solve a problem in a classical manner without list comprehension. For this example, I want to generate a list from another list, but with all the values doubled. So this is my initial list. Clicks equals, let's say 10, 5, 15 and 20. And the doubled list equals empty list. And the for loop. So for C in clicks, colon, double list dot append C times 2. And I am printing the new list. So print doubled list. I'm running the script. The new list contains all the items doubled. Okay, great. This is the classical way. But what if there's another way to do this, as I said earlier, in a shorter and more concise manner? Here is where list comprehension comes into play. This is the general syntax for list comprehension. Square brackets, and in square brackets, expression for item in iterable. Here, square brackets means that a new list will be generated. For and in are Python keywords. Expression can be any expression and is evaluated once for each item. Item is an element of the iterable, and the iterable can be any iterable object such as string, list, tuple, set, and so on. Now, let's see list comprehension in action. I'm creating a list with the same elements, but this time using list comprehension. So, doubled numbers equals square brackets and in square brackets C times 2 for C in clicks. And that's all. I'm printing the new list and running the script. And I got the same result. What we did different here is that we created the list by using a pair of square brackets, and square brackets means list. And in the new list, we added C times 2 for each C in the clicks list. In fact, we iterated over the clicks list, multiplied each element by 2, and added the result in the new list. Notice that the for loop is inside the list. This is just one line of code and it's pretty readable. Let's see some other examples. Name equals Andrei. And L1, the first list, char for char in name. Print L1. And I've got a list from the string where each element is a character of the string. The second example, L2 equals char times 3 for char in name. Print L2. And I doubled each item of the string. And the next one, L3 equals, and I'm copying the previous list comprehension, changing here like this. Char times 3 dot upper. Print L3. Now all the letters will be capitalized. Let's see another one. Franks equals Andrei, Diana, Paul, and Mary. And I can do my Franks, another list, equals list comprehension. Item dot capitalize for item in Franks. And I capitalized each word, each name. In the last example, I can reverse the list. So reversed names equals items, and I'll do a slicing. Double colons, -1. -1 is the step. For item in francs. And print reversed names. Okay, this was the first part of the section on list comprehension. We'll take a short break, and in the next lecture, we'll continue our discussion about list comprehension. I'll see you soon. Welcome back. In this video, we'll continue our discussion about list comprehension. Let's move on and see how to add a test condition. To the list comprehension syntax, I am adding if condition. Let's see an example. Let's suppose we have a list 1, 7, 8, 14, 21, 23, and 50. And I want to generate a new list that contains only numbers divisible by 7. So, divisible by 7 equals n for n in nums if n mod 7 equals 0. This is the list. I'm printing it. And I've got only the numbers divisible by 7. Though this seems confusing for a beginner, as you practice more and more, you'll get used to it. Let's try another example. What if I want to create a new list that contains the numbers from another one, first converted to strings? Like this. Nums underline str equals square brackets str of n for n in nums. I have converted the numbers, which are integers, to strings. And I've got a list of strings. Now I can join all the elements of the list into a string, like this. Print, let's say dash, dot join of nums str. If I try to use the list of integers, I'll get an error because I cannot join integers into a string that's possible only for strings. So it's not possible to call the join method with the list nums instead of nums underline str. This is an error. Expected str instance and int found. Let's move on and see some real useful examples. Let's suppose we have two lists of names and there are some duplicates. Of course, instead of names, you can have whatever you like in the lists. Some common examples are IP addresses, errors from different servers, events that took place, and so on. So, I have two lists with duplicates. Let's say Franks equals John, Dan, and Mary. And the neighbors equals Tim, Steve, Dan, and John. Now, I want to create a new list that contains the elements present in both lists. Using list comprehension, we can do this easily and fast. So, friends and neighbors, the name of the new list, equals name for name in friends if name in neighbors. And that's all. I've got a new list that contains only the common elements. But what if there are names written capitalized and names written using lowercase or even mixed case letters? How can I get the names that are present in both lists? I'm changing the lists. This is John and this is Dan. written like this. And here then, written in capitals. Now, the first list comprehension doesn't work anymore. There are no common elements in the lists. First, I'll create a new list that has only lowercase words or names. Franks underline lower equals, and a list comprehension, n dot lower for n in Franks. Let's see the list. And now I do Franks and neighbors fn equals list. And now name dot capitalize for naming neighbors. If name dot lower in Franks underline lower. And that's it. Let's print the list. And it contains common elements. We are done with list comprehension, and I hope you've enjoyed it. I find this really cool. The entire section on Python lists is complete. Next, we'll have a small project to do, then a quiz, and the challenges of the section. Lists are a key topic in Python, so please don't move on to other topics until you fully understand everything shown in this section. Take your time and practice as long as necessary. Now, you are in the process of building the foundation of your career as a Python developer. And as you already know, the foundation is the most important part of any construction. Let's go ahead and see how to work with dictionaries. The len function available to lists, tuples, strings, or sets can also be used with dictionaries. So I'm doing print len of person. This function returns the number of elements or key value pairs in the dictionary. There are 3 elements or 3 key value pairs in the dictionary. A dictionary is a mutable data type, meaning that we can change it. We can add to or remove elements from the dictionary. To change the value of an existing key, write the name of the dictionary, person, the key in square brackets, name, equals the new value. If you want to assign a value to a non-existing key, the key value pair will be added to the dictionary. For example, person of, let's say, location equals Berlin. Now I've added a new key value pair to the dictionary. Now let's get the value of an existing key. This can be done similarly to accessing elements of a list, only that we don't specify the index. We specify the associated key for the value we want to extract. For example, A equals person of age. And I've got the value associated to key age. A is 30. If the key doesn't exist, it raises a key error exception. I'm using a non-existing key, and I'll get an error. Key error. We can avoid this error by using the get method that returns the value associated with the key if the key exists, or a default value if one is specified and the key doesn't exist. If the key doesn't exist and no default value is given, it will return none. Let's see an example. Value equals person.get and the city. This is a non-existing key. And the second argument, key does not exist. And I'm printing value. and it says key does not exist because the key called city doesn't exist. But if I use name instead of city, I'll get the value associated with the key name. And it's done. Another useful method is pop. It removes a pair and returns the value of a specified key from the dictionary. If the key doesn't exist, it returns a key error. Let's see an example. Name equals person.pop of name. I'm printing the variable name, but also the dictionary. And we see the value of the variable, then that's the value associated with the key name, but we also notice that the key value pair was removed from the dictionary. Another method is pop item. It removes and returns the last inserted key value pair as a tuple. For example, print person.popitem. It will remove and return this key value pair. Location Berlin. You can just delete a pair from the dictionary without returning anything using the del statement. Like this. Del person of age. The key value pair was removed from the dictionary. And of course, if the key doesn't exist, it will raise an exception. These errors are called exceptions, and we'll talk about them later in the course. At the end of this lecture, I want to show you how to access the items of nested lists and dictionaries. I'm creating a new dictionary called Germany. By the way, for increased readability, I can write the dictionary on multiple lines. The first key will be cities, and the value, a list. Hamburg, Berlin, and let's say Munich. Next, info, the next key, and another dictionary. The value of this key will be a dictionary. Population, colon 83 million. And another pair, let's say people and some famous German people. And this will be another list. Einstein, Bach, and Gauss. Good. So, we have a dictionary with two key value pairs. The value of the first pair is a list, and the value of the second pair, of the second element, is another dictionary. Okay, now I want to access Berlin. So, the name of the dictionary, the name of the first key, cities. If I run the script at this moment, it will print out the value of this key. So the list. But I said that I want Berlin. So I go deeper and I access the element at index 1. And I've got Berlin. Now, let's suppose I want the name Gauss. How do I do that? So, the key, info, and I've got the dictionary, the entire dictionary, which is the value of this key. Now, I go deeper into it. People, I'm using the key of the dictionary, of the inner dictionary, and I've got the entire list. And I go even deeper into the list, -1, and I've got Gauss. This is the last element of the list. Of course, if I want Bach, I can use 1 instead of -1 here, or 0 if I want to get Einstein. Let's move on and see how to access the elements of a list of dictionaries. I've already created the list of dictionaries just to save some time. So we have a list called countries that contains 2 dictionaries. This is the first dictionary and this is the second. So the list has 2 elements. And I'm writing print countries of 0 and cities. What do you think it will return? Let's take a closer look. So countries of 0 means the first element of the list. And that's the first dictionary. When I write square brackets and cities, it means I go deeper into the dictionary and I get the value associated with the key called cities. So it should return this list: Hamburg, Berlin, and Munich. I'm running it. And I was right. Now I'm writing print countries of 1, info, person, and 1. What do you think it will return? Let's take a closer look at the list. So countries of 1 means the second element of the list, or the element at index 1, and that's the second dictionary. Info means the key, so I'm getting its corresponding value, this inner dictionary. Person means the value of this key, so the list. And 1 means the element at index 1. So it should return Marie Curie. Okay, we are done. In the next lecture, we'll talk about dictionary operations and methods. I'll see you soon. In the last lecture, we've discussed about serializing and deserializing Python objects using Pickle. Now it's time to take a look at another way to serialize data. In this video, we'll use JSON, which comes from JavaScript object notation and is a lightweight data interchange format. It is easy for humans to read and write, and for machines to parse and generate. JSON has become the de facto standard for information exchange. Perhaps you are gathering information through an API or storing your data from Python in a database like MongoDB. So you go with JSON if you want interoperability between applications outside the Python ecosystem, or you want a text format to store your data. Also note that JSON is more secure than Pickle. Unlike Pickle, deserialization untrusted JSON does not create an arbitrary code execution vulnerability. With all that said, it seems that JSON is preferable over Pickle, and that's true in most cases. However, there is one major drawback. JSON, by default, can only represent a subset of the Python built-in types and no custom classes. Pickle can represent an extremely large number of Python types. So in a nutshell, you use Pickle when you are not interested in interoperability and security is not of any concern to you, and you want to load the same data types that have been serialized back into Python objects. And you use JSON when you need interoperability between applications, you have security concerns, and you are not interested in preserving every Python data type. We'll talk more about this later when I'll show you some examples. Let's go coding and dive into JSON. Python supports JSON natively. It comes with a built-in module called JSON for encoding and decoding JSON data. And I've already imported the JSON module. We'll use the same Python dictionary from the previous lecture and try to encode it in JSON format. The JSON module has two functions for serializing Python objects into JSON format: dump, which saves the data to file on disk, and dump-s, which takes the Python object and returns a JSON encoded string. Let's see the first method, dump. The first step is to open a file, a text file, in write mode. With open, the name of the file, let's say friends.json. This is a text file, and I'll open the file in write mode. And the name of the file object is f. And I'm gonna call the dump function from JSON module. So json.dump. The first argument is the Python object, friends. And the second argument, the file object, f. And I'm executing the script. Let's check it. We see a new file called friends.json in the current working directory called data serialization, and inside that file we see a string representation of that dictionary in JSON format. Sometimes we just want a string representation of the Python object in JSON format. There is another function called dump-s, so with an ending s, that takes in the Python object and returns a JSON encoded string. JSON underline string, a new variable, equals json.dump-s. And the argument is the Python object. And I'm printing out the JSON string. So print JSON string. I will execute the script again. And we see here the string representation of the Python object encoded in JSON format. Remember that at the beginning of this lecture, I said that JSON is meant to be easily readable by humans. In this example, we have just a very simple dictionary. Imagine what would the JSON string look like if we serialize tons of information. It will be all squished together and not very readable. Luckily, there is another argument called indent that controls the indentation size of nested structures. And I'll use another argument called indent. And the value 4. This means I'll use 4 spaces for indentation. And I'll execute the script again. And we see the difference. It's more readable. We can use the same argument also for dump-s function. And we notice the difference. Okay, that's how we serialize data from Python into JSON strings. In the next lecture, we'll see how to deserialize or to load JSON strings into Python objects. See you in 2 seconds. In this lecture, we'll see how to deserialize from JSON into Python objects. And I'll create a new Python script for this. The first step is to import the JSON module. Then I'll open the JSON file in read-only mode. With open, the name of the file, its name is friends.json, and it's in the current working directory. And it will be opened in read-only mode, and it's a text file. Anyway, these two options are defaults for the open function, so you can write them or not. To deserialize or load a Python object, we use the load function from JSON module. So obj from object equals json.load. And it has one argument, the file object. and I'm gonna print out the type and the value of the object. This is the JSON file, and I'll execute the script. And we've got a dict with this value in Python. As with dump and dump_s, there is also load and load_s. Load deserializes from file and load_s deserializes from a JSON string. To show you this, I'll take this JSON string into a string Python variable. So JSON string equals, and I'll paste the JSON string enclosed by triple quotes. So in fact, this is a multi-line string. And I want to load the JSON string into a Python dictionary. So object equals json.loads, and the argument is the JSON string. And I'm printing out the type and the value of obj. I am executing the script. And I've got a dict variable with this value. In the JSON introduction, I said that JSON does not support all Python data types. Let me show you what I meant. Let's serialize the object again, but this time the dictionary values will be of type tuple, not list. So I'm replacing square brackets with open and closing parentheses. Now the values are of type tuple. And I am executing the serialization script again. Now back to the script that deserializes the JSON string into a Python object. I'll comment out these lines. Okay, and I'll execute the script again. And we notice that the tuple type was not preserved when loading into a Python object. Even though the dictionary values were of type tuple, when loading from the JSON string, we've got list type, not tuple. This means that JSON types are not 100% compatible with Python types. JSON defines its own data type according to this table you are seeing right now. In this table I have created for you, you see for example that a Python list or tuple has its corresponding JSON type named array. Serializing a tuple or list produces a JSON array, and then deserializing the JSON array produces a list, not a tuple. Also note that Python set type is not serializable at all. So if you want to serialize a set, you should first convert the set to a list and then serialize the list, or use pickle instead. If I add another key value pair and the value is of type set, like this, this is a set, and I try to serialize this dictionary using JSON, I'll get an error. Object of type set is not JSON serializable. In this case, you use pickle or convert the set to a list. Okay, that's how we load JSON encoded strings into Python objects. Thank you. Now that you know how to work with JSON encoded strings, I want to give you an assignment. There is a website at this address, jsonplaceholder.typicode.com, which is in fact an online REST API for testing and prototyping. You can play with this free online REST API, which is great for learning or testing different libraries like Python's JSON. What I want you to do is to make a request to the JSON placeholder API for a to-dos list. This is the list encoded in JSON. We'll make the request using a Python library called requests, which in fact implements the HTTP protocol in Python. This is not a Python standard library, and you need to install it using pip or directly in PyCharm if you use a virtual environment. I'll show you how to do it in a minute. After making the API request, I want you to load the JSON serialized data into a Python object, print its type and value. Then you'll see that there is a field in the list of to-dos called implemented, which is equal to false or true. I want you to print out only the completed to-dos, so the to-dos that have completed equals true. Okay, that's the assignment I have for you. In the next video, I'll show you how would I do it. In fact, we'll do it together. Welcome back. This lecture is the answer to the assignment given to you in the lecture prior to this one. As I said, requests library is used to make HTTP requests to web servers. This library doesn't come with Python, and we have to install it. In PyCharm, I'll go to File, Settings, search for Interpreter, then click on Project Interpreter. The next step is to click on the plus sign, and I'll search for requests. I've already installed it before, but you should install the package by clicking on Install Package. Of course, you need a working internet connection for this because it will download and install requests from a live repository. After installing requests, I'll import JSON and requests modules. Import JSON and import requests. And I'm creating a variable called response. This is the HTTP response we get from the server. Response equals requests dot get. I'll use the get method of HTTP protocol. And the argument is the URL. And I'll copy paste the address. The JSON module has a function called loadS, which is the same function we've seen in the last lecture and can be used to load a JSON encoded string into a Python object. And I'll create a new variable called to-dos equals json.loads. And the argument is response.text. The text attribute of response is the JSON encoded string received from the REST API. And I'll print its type and value. I am executing the script. We notice it's a list and this is its contents. If we look carefully, we see that it's a list of dictionaries. Now, I want to filter the to-dos, the tasks, and print out only the tasks that have been completed. We notice that there is a key in the dictionary called completed, which is true or false. And I'm gonna iterate over the to-dos list using a for loop like this. For task, this is a dictionary in to-dos, and the testing condition inside the for block of code. If task of and the dictionary's key, so completed, equals true. If the condition is true, I'll print out the task. So print task. And I am executing the script again. and we see only the completed to-dos or tasks. Okay, this was my solution to the assignment. Thank you.